Hi, listeners. This is the 80,000 Hours podcast, where we have unusually in-depth conversations about the world's most pressing problems, what you can do to solve them, and why we'll be safe as long as AGI costs more than £3,000 to build. I'm Rob Wiblin, Head of Research at 80,000 Hours. I am really pleased with how this interview with Rohin Shah turned out. I think it's going to be pretty straightforward for people with an amateur interest in AI to follow, while still having plenty of fresh ideas and opinions for people who already work in the field. Rohin is plugged into the cutting edge of AI research, having worked at Google DeepMind for years now. And he's also exceptionally even-handed, intellectually honest, and curious, so a perfect guest for this show. We talk about the current mood at Google DeepMind, Rohin's disagreements with other ML researchers, why just solving technical AI safety problems isn't enough to make things go well, what people who mainly learn about these topics from Twitter get wrong about AI alignment, what are some of the most common misconceptions that you find about risks from AI, barriers to coordination between AI labs, the most powerful arguments for and against slowing down AI advances, ways of visualizing or analogizing artificial intelligence, what observations give Rohin hope that AI is going to go well, deciding between different categories of safety work, approaches that people are using to try to push AI in a positive direction that Rohin thinks are misguided, how likely it is for public discussion of AI risks to be helpful or harmful, and which career paths Rohin would recommend for people interested in working on AI safety. One announcement before that, though. We've put together a compilation of 11 episodes from the show on the topic of artificial intelligence, including how it works, ways it could be really useful, ways it could go wrong, and ways that you and I might be able to help make the former more likely than the latter. I know a lot of listeners, of course, are looking for a way to get on top of exactly those issues right now, and we chose these 11 episodes aiming to pick ones that were fun to listen to, highly informative, pretty up-to-date, while also covering a wide range of themes by not having them overlap too much. Of course, you could find these episodes by scrolling back into the archives of the show, but the compilation should be useful because finding all those episodes in the archives is a bit of a hassle, and it puts the episodes that we think are most useful in the order that we think it's most sensible to listen to them in. The full name of that compilation feed is the 80,000 Hours podcast on artificial intelligence. It should show up in any podcasting app if you search for 80,000 Hours Artificial. So if you'd like to see the 11 that we picked out, just search for 80,000 Hours Artificial in the app that you're probably using at this very moment. All right, without further ado, I bring you Rohin Shah. Today, I'm speaking with Rohin Shah, a research scientist on the technical AGI safety team at DeepMind, one of the world's top AI labs. Rohin did his PhD in computer science at UC Berkeley's Center for Human Compatible AI, where his dissertation focused on the idea that since we have optimized our environment to suit our preferences, an AI system should be able to infer at least some aspects of our preferences just by observing the current surrounding state of the world. He's well known and much appreciated as the author of the Alignment newsletter, which has had 160 issues since 2018, and in which Rohin has regularly summarized recent papers related to AI alignment, as well as his own personal take on them. Thanks so much for coming on the podcast, Rohin.
Yeah, thanks for having me. It's great to be on this podcast. It's kind of surreal, actually, given how much I've listened to it in the past.
That's wonderful. I hope we're going to get to cover some of your personal opinions about how to ensure AI is safe to deploy and which analogies are best for thinking about AI and trying to predict what it might do. But first, what are you working on at the moment and why do you think it's important?
Yeah, so I'm a little bit split across things, but maybe I'll focus on two things in particular. One is just building and leading one of the two safety-focused teams at DeepMind, the alignment team. So I think at this point, I'm managing a few reports and giving advice on a lot of projects. So all of that, I think, is important for reasons that I'm sure listeners are familiar with. I expect everyone's at least heard of AI alignment before. And then the other thing I would say that I'm spending a bunch of time on is outreach and internal engagement at DeepMind. So just trying to get alignment work to be more sort of built into the way that DeepMind perceives all of its core priorities.
Yeah, makes sense. Are you working on any kind of particular aspect of the technical research agenda, or it sounds like you kind of have a more high-level role?
Yeah, I think in the end, I end up advising many different projects as opposed to working specifically on one. I'm actually just wrapping up a project on understanding this phenomenon called grokking. So that one was one where I was a lot more involved in the day-to-day research. So that was pretty exciting. I think it was a more speculative project of like trying to see, okay, if we understand this particular weird phenomenon about how deep learning works, maybe that would give us some sort of insight that we could then leverage for alignment proposals. And I don't think that quite panned out. I'm still pretty excited about the general direction of like understanding deep learning. And I do think we did like scientifically good work where like I do actually feel like I understand this phenomenon a lot better. I think the part where, and then it helps with alignment somehow, hasn't fully panned out.
Yeah. Okay, well, let's get into the meat of the conversation today. I guess something to observe early on, I think, is that we've done quite a few episodes on AI over the years, and we're going to be doing quite a lot more in future, given what a hot topic it is at the moment. I suppose recently we've had on both Richard No and Ajay Kotra, and they've kind of laid out why they think there's some things to worry about here, as well as almost, I guess, unlimited upside potential if we can really nail it. Further back, we've heard from Chris Olah, Brian Christian, Ben Garfinkel, Stuart Russell, Paul Cristiano, Pushmit Kohli, Catherine Olsen, and Daniel Ziegler, Katja Grace, Dario Amade, and I think a couple of others besides. So I think as we I guess are doing more and more episodes on this general theme, in order to make sure that we're doing new stuff each time and not kind of just repeating ourselves, I think we're going to spend a bit less time on the basics and maybe think more about the kind of the personal opinions that each guest has and ways that they see things differently than other people. So I guess the typical structure in the past has kind of been spending the first hour laying out the problem as that guest sees it. But we're going to spend I guess have a more fluid structure, I think, in future and jump around just on what kind of are the most interesting opinions that person happens to have. I guess with you, Rohin, I also want to take advantage of the fact that you're at DeepMind, well, one of these main labs trying to develop AGI. I guess to hear what the mood is there specifically. So I guess let's start there. Obviously, it has been a pretty hectic 3 months for AI. It's been all over the news. And I suppose more broadly, I guess you could say it's been a hectic 6 months or 1 year, or I guess even decade if you zoom out from one point of view. What is the mood at the DeepMind offices as far as you can tell?
Yeah, so I think there's been quite a lot of stuff happening, and it's definitely affected the mood at DeepMind. But it's just, DeepMind is such a big place. There's such a wide diversity of people and opinions and so on that I don't really feel like I actually have a good picture of all the ways that things have changed. But like, I don't know, to take some examples, there's obviously a bunch of people who are concerned about existential risk from AI. And so, I think many of us have expected things to heat up in the future and for the pace of AI advances to accelerate. But seeing that actually viscerally play out is like really leading to an increased sense of urgency and like, man, it's important for us to do the work that we're doing. Then there's like a contingent of people who, I think view DeepMind more as like a place to do nice, cool, interesting work in machine learning, but weren't thinking about AGI that much in the past. And now I think it feels a lot more visceral to them that like, no, actually, maybe we will build AGI in the nearest future. And so I think this has caused people to change in a variety of ways. But one of the ways is that they tend to be a little bit more receptive to arguments about risk and so on, which has been fairly, I don't know, vindicating or something for those of us who've been thinking about this for years. And then there's also like a group of people who are kind of look around at everybody else and are just a little bit confused as to why everyone is reacting so strongly to all of these things when it was so obviously predictable from the things we saw a year or two ago. And I also feel some of that myself, but there are definitely other people who lean more into that than I do.
So on the potentially greater interest in your work, I guess I would expect that people would be more interested in what the safety and alignment folks are doing, because I guess one reason to not take a big interest in the past was just thinking that that's all good and well and might be useful one day, but the models that we have currently can't really do very much other than play Go or imagine what a protein how it might fold. But now that you have models that seem like they could be put towards bad uses, or indeed like might semi-autonomously start doing things that weren't desirable, kind of push has come to shove, and it seems like maybe DeepMind and other labs need the kind of work that you folks have been doing in order to make these products safe to deploy.
Yeah, that's exactly right. Like at this point, it's something like, alignment work, or just generally making sure that your model does good things and not bad things, which is perhaps a bit broader than alignment, is sort of the bottleneck to actually getting useful products out into the world at this point. Like we've definitely got the capabilities needed at this point to build a lot of useful products, but can we actually leverage those capabilities in the way that we want them to be leveraged? Not obviously, yes. It's kind of unclear right now. And yeah, there's just been an increasing recognition of that across the board. This is not just about alignment, but also the folks have been working on ethics, fairness, bias, privacy, disinformation, etc. Like, I think there's a lot of interest in all of the work they're doing as well.
Yeah. Is it possible to indicate roughly what the ratio is of excitement to anxiety about all of this?
Oh man, do I actually know? I'm not sure that I do. Like, I'm definitely in the sort of like section of DeepMind that I'm in. You definitely see a lot more of the anxiety, but that's partly because the people who are feeling anxious often, come to the like AGI safety or alignment Slack channels and go like and ask questions about like, well, what are we actually going to do about these risks? So of course, I tend to see more of the anxious side. I think there is also a lot of excitement about the capabilities and what we could really achieve with them, but I tend not to see that as much. So it's a little hard for me to say exactly what the ratio is.
Yeah, I guess that old quote from Arthur C. Clarke just jumped into my mind that like any sufficiently advanced technology seems like magic, and I really do feel like I'm living through a time when we're inventing magic. GPT-4, it's just extraordinary what it can do.
It really is.
Yesterday, I listened to the interview that Tyler Cohen did with ChatGPT-4 pretending to be Jonathan Swift, this Irish author from the 17th and 18th centuries, and it was just extremely impressive.
Huh, really? Yeah, I've not seen that, but that does sound like a sort of thing it could do. I think for me, one of the like craziest things, maybe not craziest, but like most viscerally impactful things was, at least this was the thing that I'd seen someone claim, that GPT-4 can predict the output of scripts that are doing Monte Carlo simulations. That just seems kind of wild. So like you write a Python script that is doing some sort of Monte Carlo simulation to estimate some quantity, which would be hard for, humans to do. It just sort of got this like mathematical reasoning about what a script would output. And GPT-4 is actually not bad at this, which is kind of wild to me.
Yeah, that's okay. So Monte Carlo simulations, it's something where you're trying to figure out the distribution of some output for a wide range, a distribution of possible inputs into some process or some formula, and it's able to look at a piece of code that is trying to run these simulations and just kind of guess intuitively what distribution of output you might roughly get.
Yep, that's right. Well, it's usually a point estimate rather than a distribution, but it's a point estimate of some quantity that comes from a distribution. Yes. Yeah.
Do people inside who are doing ML research find it similarly unnerving that we just don't know what these models are capable of doing?
That's a good question. Definitely some of them do. I think maybe like the biggest theme in ML research, or maybe conversation about ML from ML researchers in the last year or two, might be this theme of emergence, of like, you increase the size of your neural network, and then suddenly these new capabilities emerge from scale. And then not only that, but also like you don't even know what the capabilities are until someone actually thinks about probing them and finding them and demonstrates them. And then you're like, oh, I guess that's another thing that the models can do that we didn't know about. Like, it sort of feels like, even before everyone had figured out what, the various models prior to GPT-4 could do, like there were still new capabilities being discovered. And then GPT-4 came along and there's a whole bunch of new capabilities to be discovered.
Yeah, I can't think of any other human invention that has this property. I mean, maybe there is something, I don't know, it sounds like a riddle. Yeah. What invention, what invention do you create, but you don't know what it does? Is it possible to give a short summary of what sorts of things safety folks at DeepMind are up to at the moment? I guess a brief one, because we'll come back to it later.
Yeah. So I'll focus more on the technical research. We do also do a lot of internal outreach and engagement, as I mentioned a bit before. But on the technical side, there's a lot of work on scalable oversight. So essentially trying to improve the quality of human feedback that you use to train an AI system. Work on mechanistic interpretability, so trying to understand how a model is making the decisions that it's making. work on dangerous capability evaluations. So just seeing for our current models, could they actually do something dangerous if they quote unquote wanted to? Where right now the way we do that is we just try to train them to do dangerous things and see how far they get. Obviously in simulation where nothing actually bad happens. But the sort of principle here is like, let's know what the models can do before we, in simulation, where we can actually like monitor them before we try and do something where we aren't monitoring them.
Yeah, makes sense. Okay, let's get to jumping around a little bit. I guess, the first thing I was interested to ask about is common misconceptions or places where you maybe disagree with listeners or with things that one often hears. Yeah, what is something that you think a meaningful fraction of listeners out there might believe about AI and its possible risks and benefits that is, in your opinion, not quite on the mark?
Yeah, I think there's a common meme floating around that like once you develop AGI, that's sort of the last thing that humanity does. After that, our values are locked in and like either it's going to be really great or it's going to be terrible. And I'm not really sold on this. I think, so one, I guess I just see I have a view that AI systems will become more powerful relatively continuously. So there won't be like one specific point where you're like, this particular thing is the AGI with the locked in values. This doesn't mean that it won't be fast, to be clear. I do actually think that it will feel crazy fast by like our normal human intuitions. But I do think it will be like capabilities improve continuously and there's not one distinct point where everything goes crazy. And so that's part of the reason for not believing this lock-in story. The other part of the reason is I expect that AI systems will be doing things in ways similar to humans. So like, it will not have like, okay, this is the one thing that the universe should look like, and now we're going to ensure that that happens. But especially if we succeed at alignment, instead, it will be the case that the AI systems are helping us figure out what exactly it is that we want through things like philosophical reflection, ideally, or maybe, the world continues to like get technologies at a breakneck speed and we just sort of frantically throw laws around and regulations and so on. And that's the way that we make progress on figuring out what we want. Who knows? But probably it will be similar to what we've done in the past as opposed to some sort of value lock-in.
I see. So if things go reasonably well, there probably will be an extended period of collaboration, I suppose, between these models and humans. So it's not humans aren't going to go from making decisions and being in the decision loop from one day to being completely cut out of it the next. It's maybe more of a gradual process of delegation and collaboration where we trust the models more and give them kind of more authority, perhaps.
That's right. And also like that's definitely one part of it. And another part that I would say is that we can like delegate a lot of things that we know that we want to do to the AI systems, such as like, acquiring resources, inventing new technology, things like that, without also delegating. And now you must optimize the universe to be in this perfect state that we're going to program in by default. We can still leave the, what exactly are we going to do with this cosmic endowment in the hands of humans, or in the hands of humans assisted by AIs, or to some like process of philosophical reflection, or, I'm sure the future will come up with better suggestions than I can today.
Yeah. What would you say to people in the audience who do have this alternative view that humans could end up without much decision-making power extremely quickly? Yeah. Why don't you believe that?
So I guess I do think that that's plausible via misalignment. So this is all like conditional on us actually succeeding at alignment. If people are also saying this, even conditional on succeeding at alignment, my guess is that this is because they're thinking that success at alignment involves like instilling all of human values into the AI system and then saying go. And I think I would just question why that's their vision of what alignment should be. It doesn't seem to me like alignment requires you to go down that route, as opposed to like the AI systems are just doing the things that humans want. And in cases where humans are uncertain about what they want, the AI systems just like don't do stuff.
Yeah.
Take some cautious baseline.
Yeah, I think that vision might be a holdover from a time when we didn't know what ML systems would look like, and we didn't know that there were going to be neural nets that were trained through incredibly large samples of examples, and then they would end up with intuitions and values that we can't exactly see because we don't understand how the neural networks work. I think in the past people might have thought, oh, we'll program an AI to do particular things with some quite explicit goal, but in practice it seems like these goals are all implicit and learned merely through example.
Yeah. I guess if I imagine talking to a standard person who believes more in like a general core of intelligence, I don't think that would be the difference in what they would say versus what I would say. I would guess that it would be more like, I think it would be more like, look, once you get really, really intelligent, that just sort of means that you're going to, as long as you have some sort of goal in mind, you're just going to care about having resources. And if you care about having resources, you're going to take whatever strategies are good for getting resources. That doesn't really matter whether we programmed it in ourselves or whether this core of intelligence was learned through, giant numbers of examples with neural networks. And then I don't quite follow how this sort of view is incompatible with we will have the AI systems have, this sort of collecting a bunch of resources for humans to then use for whatever humans want. It feels like it is pretty coherent to have a goal of like, I will just help the humans to do what they want. But this feels less coherent to other people. And I'm like, don't super understand exactly why.
Yeah. Okay, another misconception. I guess, this time, this one's from the audience. If people mostly learn about AI safety from Twitter or the Alignment Forum or random articles and blog posts on the internet, what are they most likely to be missing and or what mistakes are they most likely to make other than perhaps only using those sources of information?
Yeah, so as an avid less wrong user, of course, I am going to be very critical of less wrong. It's just you have to be in order to be a less wrong user. But yeah, so I've got a few of these. Maybe the first one I'll mention is that you're maybe more likely to treat worst case reasoning as a method for estimating probabilities of what's actually going to happen.
What do you mean by that?
So like saying, okay, here's this particular technique for potentially aligning an AI system, and then thinking, okay, but if I were a misaligned superintelligence, here is the way I would defeat that technique, and therefore that technique is not going to work. That's sort of saying like, in the worst case where the AI system that you're trying to align is already misaligned and is super intelligent, then this technique doesn't work. And then from that, going to an inference of, and so this technique isn't going to work at all in any case, even if the AI wasn't already a misaligned superintelligence.
Yeah. And why is that mistaken reasoning?
Yeah. So obviously sort of the general pattern of let's think about the worst case and then predict that's going to happen in reality seems pretty clearly wrong. Now, in the AI case, it's less clearly wrong than in that case, because with AI, the thing we are worried about is an AI system that is adversarially optimizing against you, that is more intelligent than you are. So in that case, if you had this sort of adversarial optimization, it would be pretty reasonable to say, well, the worst case is X, and so probably the AI system will also find something at least as good or bad, depending on your perspective, as X. And so that's probably what happens in reality. But in most discussions about AI alignment, most techniques for alignment that people talk about, they're meant to apply before the AI system has become a misaligned superintelligence. In the limit, you can start applying these techniques often from the point where you start with a neural network whose weights are randomly initialized, which is definitely not exerting any adversarial pressure against you. And so at that point, there's not actually any adversarial optimization going on against you. And so at that point, I don't think the worst case reasoning argument goes through directly.
I see. Okay, so the idea is many alignment methods are meant to come early on before you have a superintelligence that is trying to outwit you and be deceptive and so on. And it's true that if you only applied them after that had already happened, once you already had a being that was hostile and trying to like maximally achieve its goals to your detriment, then applying it at that stage would be no use. But if you'd done it earlier during the training process, before this being existed or while it was gradually developing capabilities, then it might work in that instance.
Yeah, that's exactly right.
Okay. Yeah. Any other common misconceptions from people who get their stuff on the internet?
Yeah. I think another one is sort of treating analogies as a strong source of evidence about what's going to happen. So the one that I think is most common here is the evolution analogy, where the process of training a neural network via gradient descent is analogized to the process by which evolution searched over organisms in order to find humans. And so just as evolution produced an instance of general intelligence, namely humans, similarly, gradient descent on neural networks could produce a trained neural network that is itself intelligent.
Hey listeners, Rohin used the term gradient descent, which we're all going to be hearing a lot about in coming years, I think. So I thought I'd take a moment to explain what that refers to. If you already have a good idea, you can skip forward a minute or two. Gradient descent is basically an optimization algorithm used in machine learning and AI to find the best model or the best set of parameters, or sometimes called weights, to solve a particular problem. You can kind of visualize gradient descent as a way of finding the lowest point in a mountainous area of land with lots of peaks and troughs and valleys. We start basically at some random point on this space. Then we choose to walk downwards, basically slowly sliding down the side of the hill towards the valley. And in order to do that, you take small steps in the direction that takes you furthest downhill. So at each point, you check which direction is downhill by looking at the slope of the hillside in each direction. And then you take a small step downwards. And you repeat that process over and over, walking slowly down the side of the valley. And eventually, you reach the bottom or the lowest point. Now, in machine learning, the valley is actually a cost function, and you want to find the minimum point, the point where you have the smallest level of error. And the slope is telling you the direction that you want to move each of the parameters in the model in order to decrease the error or the loss. By iteratively moving in the direction that reduces the error the most, you hopefully eventually find the minimum point, which will give you the best solution for the model. The key idea is that you want to gradually slide down the gradient towards an optimal solution by taking small steps in the direction of the steepest descent at each point. Of course, in the mountainous region case, there's only two dimensions that we're talking about here. You've got a direction in one way and then the other perpendicular direction. When you're creating an ML model, you might have thousands, millions, possibly billions of different parameters that you could potentially shift in one direction or the other. So you're moving through a much higher dimensional space, but you can still get the basic idea by imagining a two-dimensional plane where the height, the up and down axis, indicates how well you're doing, and you're trying to get to the lowest point, the lowest level of error. All right, hopefully that's not too wrong, and I don't get that many angry emails. We'll get back to the interview.
Yeah, actually, the analogy as I stated it is seems fine to me. But then I think it's just often pretty common for people to take this analogy a lot farther, such as saying well, look, evolution was optimizing for reproductive fitness, but produced humans who do not optimize for reproductive fitness. We optimize for all sorts of things. And so similarly, that should be a reason to be confident in doom. And I'm I don't know. This is definitely pointing at a problem that can arise, namely inner misalignment or goal misgeneralization or misoptimization, whatever you want to call it. But it's pointing at that problem. It's enough to raise the hypothesis into consideration. But then if you actually want to know about how likely this is to happen in practice, you really need to just delve into the details. I don't think the analogy gets you that far.
Yeah, one place where I've heard people say that the analogy between training an ML model and evolution might be misleading is that creatures, animals in the world that evolved had to directly evolve a desire for self-preservation because mice that didn't try to avoid dying didn't reproduce and so on. But there isn't a similar selection pressure against being turned off among ML models. Do you think, does that make sense as a criticism? And I guess I think that you could end up with models that don't want to be turned off because they reason through that is not a good idea. So the same tendency could arise via a different mechanism, but maybe they have a point that you can't just reason from this is how animals behave to this is how an ML model might behave.
Yeah, I think that all sounds valid to me.
Yeah.
Including the part about how this should not give you that much comfort because, in fact, they can reason through it to figure out that staying on would be good if they're pursuing some goal.
Yeah. What do you think is an important disagreement you have with the majority of ML researchers at DeepMind, if there are any particular things that the majority of researchers at DeepMind do believe?
This is probably just going to be about the majority of ML researchers in general, because there's not that much that differentiates ML researchers at DeepMind, which are a very diverse group, from ML researchers everywhere else, except maybe more of a focus on deep learning. But I do agree with that part. But one disagreement I do have with ML researchers overall is just like how much you can trust some conceptual arguments. Like, I think the field of ML in general is fairly allergic to conceptual arguments because, like, for example, people have done a lot of theory work trying to explain how neural networks work, and then these just like don't really predict the results of experiments all that well. And so there's much more of a culture of like, do the experiment and show it to me that way. I'm not just going to buy your conceptual argument. And I like kind of agree with this. I definitely think that a lot of the conceptual work on the alignment forum feels like just it's not going to move me that much. Not necessarily that it's wrong, just that like it's not that much evidence because I expect there are lots of counter arguments that I haven't thought about. But I do think that there are occasionally some conceptual arguments that do in fact feel really strong and that you can update on. And I think many ML researchers, even if you present them with these arguments, will still mostly be like, well, you got to show me the empirical results.
What's an example of one of those?
Yeah. So I think one example is the argument that even if you have a correct reward function, that doesn't mean that the trained neural network you get out at the end is going to be optimizing that reward function. Or let me spell that out a bit more. So what happens when you're training neural networks is that even in reinforcement learning, which we can take for simplicity because probably people are a bit more familiar with that, like you have a reward function, but the way that your neural network gets trained is that it gets some episodes or experience in the environment, and then those are scored by the reward function and used to compute gradients, which are then used to change the weights of the neural network. If you condition on what the gradients are, that fully screens off all of the information about the reward and also the data, but the important point is the reward. And so if there were like multiple reward functions that, given the same data that the agent actually experienced, would have produced the same gradients, then there's just the neural network that you learned would be the same regardless of which of those multiple reward functions was actually the real reward function that you were using. And so you should be even if you were like, the model is totally going to optimize one of these reward functions, you should not, without some additional argument, be confident in which of the many reward functions that are consistent with the gradients the model might be optimizing.
So to see if I've understood that right, is this the issue that if there are multiple different goals or multiple different reasons why a model might engage in a particular set of behaviors in theory, then merely from observing the outputs, then you can't be confident which one you've actually created because it's just multiple, because they would all look the same.
Yeah.
Is that right? Okay.
Yeah, that's right.
And you're saying, I mean that makes sense, doesn't it? So, but you're saying ML researchers aren't so interested in this because this is more of a theoretical argument rather than one that has been demonstrated through example?
So I think probably the important thing is usually I would go further from that and talk about how you could have both the aligned AI system that like tries to do what you want and also a deceptive AI system that, wants to make paper clips or whatever, replace whatever goal you want, but knows that if it shows signs of its deceptiveness, then humans will turn it off. And like both of these AI systems would behave the same way. They would get high reward if you were training them with a loss function that was basically what humans want. Both of them would score very well on this loss function. And so gradient descent would be like, good job, you are a good neural network. I do not want to change you.
Okay. And the point is that they would be producing the same output and behaving the same way for completely different reasons, and you just can't distinguish.
That's right. And gradient descent isn't going to distinguish between them, so you shouldn't be particularly confident that you get one over the other. I think once you get there, ML researchers are often like, intriguing argument. I don't see any flaws in it. and then they will go back to what they're doing fairly frequently, which I think is a symptom of like, yeah, this person managed to make a convincing, smart-sounding argument that I couldn't find any holes in. But like, people have done that in the past. Theory researchers do it all the time. And it's still usually correct to like just ignore those arguments. So I'm going to ignore this argument too. I don't think they're consciously doing this, but I think that's sort of the like learned response.
Right. Yeah, I think this tendency or this aesthetic is common across many areas of science and engineering, where people learn that the best way to do their kind of job or their kind of research is not to think big thoughts and make arguments that sound more philosophical, but rather just to like stay at the coalface and or like cross the river by filling for the next stone, basically. Mm-hmm. And I guess, yeah, try to be super empirical and ignore theoretical arguments even when they kind of sound good. That's all well and good probably in some circumstances, but I think it's actually an incredibly dangerous tendency when you're dealing with technologies where, it could be dangerous in many different circumstances. In particular, I guess when you're working on something where you can't be confident that the trend that you're currently working with is simply going to continue, that there could be some sharp turn in the way that things go. And kind of the only way that you'll be able to see that far ahead into the fog of where your research might lead you is by being somewhat more theoretical, is by being somewhat more conceptual, because you can't do the empirics yet, because you're trying to estimate, where you'll be in 5, 10, or 15 years, several steps down the road. Yeah, so I find it deeply troubling when it's very hard to get people working on dangerous technologies to think more at this level.
Yeah, I do wish that would happen more. I do think it does happen. So, for example, I would say that, like, the way that Stuart Russell got interested in AI safety, I think the way he tells it is that he, I forget exactly how this happened, but he asked himself the question of, like, what would happen if we did succeed? Which is not a question that people usually ask themselves very much, sadly. But he did ask the question, and then he thought about it. He was like, actually, that seems like maybe an important problem, and we should figure out what to do about it.
Yeah. This maybe isn't a paradigmatic example, but one that jumps to mind is I've seen biologists thinking about the risks of gain-of-function research or dealing with creating possibly dangerous pathogens in the lab and saying, well, it's not a problem because we don't have any examples of pandemics that have been caused by, this is all just like, in principle, maybe it could in theory, but, show me the empiric, show me the case where this is leaked. I'm like, but we kind of...
What?
I mean, it sounds very strange, I guess, in this context, but I think it makes more sense if you just have this like intensely empirical, like preference for empirical information, and someone saying that something could be dangerous, maybe, just isn't very compelling to you. I don't want to say that that's a typical response, but I think someone with a particular, aesthetic for how you learn about the world might be inclined to think that way.
I hope they were asking for like a pathogen that we can see is dangerous to mice or something, as opposed to a pathogen that like wipes out 10% of humanity, and then I will be convinced that in fact this is maybe dangerous. I'm like, you really want to not have the catastrophic risk happen before you're convinced that the catastrophic risk might happen.
I suppose to defend these folks, that the principle that someone who was worried about something that has never happened before probably is being a nervous Nelly, and you shouldn't worry too much. Like in most cases, saying, but this has literally never happened ever is a good reason not to worry about it. In this case, it doesn't work so well because the reason why it might not have happened is that, well, we haven't been doing this kind of research all that long. And I guess we're not even 100% sure that it hasn't happened. But I guess it's when the scale of the harms is so large that you just can't trust, like that's not a sufficient response anymore.
I don't know. I think I have a little less sympathy than you do for this position. I sort of feel like in situations like this, you should at least be able to name some concrete empirical evidence that you could expect to get before the catastrophic risk happens that would change your mind in some direction, at least get you to the point of like, all right, I'm going to spend a bunch of time thinking about this. So like in the pandemic case, they're like, here's gain of function that can like, I don't know, reach some threshold of virulence in mice. I made up that example, but something along those lines. And similarly for AI, I think you could, I don't quite know exactly what everyone's personal thresholds are for when they'll be thinking about AI risk. Plausibly, just the existence of Bing Chat has already passed it for many of them. But you could maybe say things like, well, maybe you've got to make the simulated world where there are, stand-ins for humans going around, and the AI system has to disempower people in that world, which is a standard that I don't think we've achieved yet with empirical examples, but it is a standard that I think we plausibly could achieve before the catastrophic risk actually arrives. And it is something that I would like to work on, but not because people have told me this is what will convince me, more because I'm like, well, if I model people and try to imagine what would convince them, maybe it's something like this. But I'd feel a lot better if people were just actually telling me this is the thing.
Yeah. Okay, let's push on from misconceptions and talk about just some of the personal opinions you have about the nature of the challenges we might face with AI. I guess, first up, how likely do you think it is that kind of the key few ways that AI could one day run amok are already known in some sense and are nicely characterized and characterized accurately, as opposed to it being some sort of phenomenon that we just haven't named and talked about yet?
Yeah, so focusing primarily on misalignment for this part, where by misalignment, I usually mean cases where an AI system is knowingly acting against the wishes of what its designers want. So it's taking some actions that it knows that if its designers were fully well informed about what it knows about its actions, then the designers would be like, no, that's not a thing you should do. And the AI system knows that. So if we talk about that particular problem, then I think there's one part of the story that feels pretty constant throughout, which is this notion of goal-directed AI systems. So I could say a lot of words about this, but in the spirit of saying only a few words about this, roughly this part of the argument says, if you have an AI system pursuing a goal that, benefits from getting more resources, then it will have a lot of convergent instrumental sub-goals, where convergent means it happens for a wide variety of final or terminal goals. Instrumental refers to the fact that it's not the final or terminal goal.
It's a means to an end.
Yeah, exactly. It's a means to an end. And there are various of these sub-goals, as we mentioned before, staying alive, which in this context means more make sure something with roughly my goals continues to operate. It doesn't necessarily have to be quote unquote me. It could be some copy or some future successor. Gaining resources and power, deceiving humans to the extent that your goal conflicts with what they want, overpowering the humans if they're going to try and stop you. And so I think this rough story of if the AI system is pursuing some goal and is flexibly planning in order to achieve that goal, it would choose plans that exhibit these sorts of deceptive features. That part of the story, I think, is pretty solid. It's basically stayed the same throughout the existence of the field. I don't really expect that to change. There's a different part of the story, which is well, why is this AI system goal-directed and pursuing, in particular, a misaligned goal that's not the ones that humans wanted? And that, I think, depends a lot more on how you expect to build the AI system. And there, I think it's entirely plausible that we think of new ways in the future. So maybe I can just name a few that we've already thought of right now.
Yeah, go for it.
So there's if you thought that you were going to use sort of more classical AI approaches like search or logic or state estimation or probabilistic programming and all of that stuff, those methods tend to be the humans write down code that is quote unquote intelligent, and then there's a spot in that code where you can plug in a utility function or a goal. And so there, the thing that you might be worried about is, well, are we actually able to write down a goal that actually captures everything that we want? So this is a little bit more echoing sort of some of the classic arguments. I think that mostly is the right sort of thing to be thinking about if you were expecting AGI to be built that way. Then there's, if you're instead thinking of building powerful AI systems via deep learning instead, then one thing you could think is that a lot of the intelligence is the intelligence part of is in the forward pass of the neural network. Its goals are baked into the weights of the neural network. And then you start being a little bit more worried about this goal misgeneralization, inner misalignment type stuff that we were talking about just before.
Sorry, what's a forward pass?
Sorry, a forward pass is just if you run the neural network on a single input to produce a single output from the neural network.
Okay, yeah.
Yes, sorry for the jargon.
It's hard to avoid. Sorry, yeah, yep. Go on.
So another thing is you might think that actually and this is a common view of large language models is that their forward pass is just predicting the next token, the most likely next token of language. And what they're actually doing under the hood is simulating a bunch of possible completions to the text and then just sampling according to that probability distribution. In that situation, you're like not that worried about the system having goals, but you might be worried that when it's like simulating the distribution to sample from, part of that distribution might be like an evil monomaniacal dictator or something. And then it starts thinking about, well, if this text was being produced by that dictator, how would that be continued? And then maybe it's like, well, yes, the dictator would try to get a bunch of power, and so it would like start deceiving the humans and so on. So there it's like, this is like an idea of goal-directedness via misaligned simulacra would be the words that people use to describe that one.
Okay. So I guess that one sounds a little bit, well, I mean, I suppose I'm constantly surprised by what things happen, but I feel like I'm more intuitively skeptical that that's how things are going to play out. But I guess you're saying that's another story by which kind of a similar phenomenon arises that some people have worried about.
Yeah. And I think I'd roughly agree with you that it's not that likely, but my reasons for believing this are that I expect that what we will do is use techniques like RLHF, reinforcement learning from human feedback, to convert LLMs, large language models, from this more simulatory kind of thing into more goal-directed in the sense of like their goals are baked into their weights type models. And so because I expect this sort of thing to happen, I'm like, okay, probably that's what's going to be the more realistic threat model.
Yeah.
But if I were like, well, we're just never going to do RLHF. We're just going to scale up just the like text prediction models way out into the future. Then I start being a little bit uncertain. Like maybe I'm like, actually, perhaps the misaligned simulacra thing is not crazy.
Yeah. So is the basic story here that so you think you're making a large language model that is just trying to predict the next word, or that's how it's achieving the output. But as part of the training, the way that it ends up doing that is creating an agent internally that has goals, or it ends up simulating what it would be like to be an agent that has goals, because that is how you would figure out the next word that such an agent might say. And then basically that agent inside this broader neural network kind of takes over the neural network, and then it actually starts to act as if it's an agent rather than merely a network that tries to predict the next word.
Yeah, that's right. With more of an emphasis on simulating the agent rather than internally containing the agent. I think internally containing tends to give you the wrong sort of intuition about what's going on.
Okay, and I think that the next thing on your list here, the next way that this might happen, is that we actually just deliberately make an agent with goals, and so it arises quite consciously. Is that right?
Yeah, that's roughly right. Or at least I would say maybe the way I would frame it is that we fine-tune these large language models to more explicitly be doing things like figuring out whether or not the things they're saying are true, or using planning and reasoning in order to come to more correct outputs and so on. And like all of those things together seem like they're going to produce they're going to make the neural network itself more, in some sense, agentic or goal-directed. Though I personally tend to prefer to talk more about the like, just is it doing planning and reasoning, and like what are those aimed towards?
I see. Okay, so to bring this together, you were saying that although there are many different specific stories about how any particular training process could end up going wrong, or how any particular design might end up, with unintended consequences, there's a common thread through all of them, which is this issue of you ending up with an agent that has particular goals that are not necessarily the same as yours, and then it kind of wants to seek power in order to achieve those goals at your expense. Is that the point you were making?
Yeah, that's right. I maybe should mention the one that I feel like I worry most about.
Oh, yeah.
Which is none of the three above.
Yeah.
Maybe it's kind of like the second one. But, I talked about the AI system having a goal that comes through with every single forward pass, so every single like converting one input into one output. I think the much more realistic story is that you have AI systems that for every forward pass are not particularly goal directed, but like when they are doing these sorts of chains of thought where, they produce one token, then that token gets added to the input that produces the next token, and so on. So they build these long streams of multiple forward passes building upon each other in order to do reasoning in text. It seems much more plausible that, like, you know, as it does this sort of chain of thought reasoning in text, that process does a lot more reasoning and planning and so on that makes it more goal-directed than any individual forward passes. And then I'm like, actually, the goal-directedness is in that overall reasoning process as opposed to just in the weights of the neural network.
And that's the thing that you're most worried about?
I think that seems like the most likely story for how goal-directed AI comes about in the future.
I see. Wouldn't it just be that we wanted to make an agent, that we deliberately train an agent to, you know, be a personal assistant?
Yeah, totally. And the way that will work is
this.
Yes.
Okay, interesting. Do we have a different way in mind of creating agents that would do work on our behalf?
Yeah, there are a lot of things that are relevant to that. So, for example, you could really be more bullish on actually we'll make really big models, and we'll be able to like get it so that they're a single forward pass of theirs is like more agentic, can do planning and reasoning or something along those lines. So that's one thing. Then there's other things like we will give the neural network access to tools that it can call externally. And then by using those tools, it can produce significantly better and more reasoned outputs than it would have otherwise. So for example, one paper out of DeepMind, which is about trying to get the large language models to be more factual, talks about how you can enable your large language model to do information retrieval over a large database of text. And so that allows it to like more easily do citations of things that humans have said on the internet.
Yeah.
And so there's just like a lot of things like this that can be used to boost your AI system's ability to be an assistant. And it's kind of unclear on how all of that plays into like goal directedness and so on. Probably in the end, we just need to like think about like, okay, concretely, can we come up with some stories about how the assistant might do bad things that it still gets rewarded for? And then say, okay, what can we do in order to make that happen less or not happen at all?
How hard do you think it's going to ultimately prove to be to make systems like this that don't knowingly go against the wishes of their designers?
Yeah, I don't know is mostly the answer. And then maybe the more interesting answer is I also don't think that anyone else has good reason to be confident one way or the other. I'm like, given the evidence that we have now, and given the fact that humans are limited reasoners and are not omniscient, it does not seem very reasonable to me for anyone to be particularly confident in a view on how hard this problem should be. Now, it's obviously possible that somebody has information or arguments that I just don't know about. But at this point, I think that's reasonably unlikely.
I guess you've looked pretty hard for arguments,
yes,
one way or the other, and not been persuaded.
That's right, including by like talking to a bunch of the people who have thought the hardest about this.
Right. And I guess your experience has been that there are some people who think that this is going to prove exceedingly difficult and we're kind of doomed to failure. And there's other people who think that this is a trivial issue and one that will almost inevitably be solved in the natural course of events. And I guess there's some people in the middle as well. But you just think none of them really have very strong reasons to believe one thing rather than the other.
Yeah, that's right. I basically just disagree with both of the extremes. The people in the middle I might agree with.
Okay, yeah. It seems like given if we're extremely uncertain about how difficult the problem is, it makes the most sense to act as if the difficulty is somewhere in the middle, because if the problem is virtually impossible to solve, then probably we're just screwed no matter what. And if it's really trivial to solve, it also doesn't really matter that much what we do. Whereas if it's in the middle, then, putting a bit more effort into this or being a bit smarter about what efforts we engage in might make the difference between things going better and worse. Does that reasoning make sense?
I would say yes, that reasoning does make sense. I would prefer to frame it a bit differently. The way I usually think about it is that the actions I take, every action I take that's, meant to be about this, about solving AI risk, there should be some world, some concrete world that I can ideally that I could describe, and which just makes the difference between like doom and not doom. Now, for any given action, especially small scale actions, it's going to be in a like extremely, extremely detailed and implausible concrete story. Something where you're like, what? That's definitely not going to happen. 1 in a billion or whatever. That's fine. but there should be some world in which you can make this sort of story. And it doesn't have to be via technical things. It could be like, because I did this 80K podcast, some brilliant ML researcher out there listened to it on a whim and was convinced to work on alignment, and they came up with this brilliant idea that when combined with all of the other techniques meant that the first lab to build a like extra risky system made sure to build ended up building one that didn't cause doom instead of one that did cause doom. And it's like, yeah, that's an extremely conjunctive, implausibly concrete chain of events, but like also is like 180K podcast. Obviously, it's going to be, the chance that this particular podcast is going to be the difference between doom and not doom is obviously extremely tiny.
You're breaking my heart, Rohin. Right, but you're saying there's a difference between extremely tiny and just there is no such story that you could possibly tell.
Exactly.
Okay, yeah.
I should maybe also emphasize that like, it's not just that there should be some story rather than no story. Also, you want, the best possible story you can, given holding constant the amount of effort you're putting in. But I do like the idea, like, I'm not as keen on people like really trying to like optimize for the best story. That seems a lot harder to do, and often I just prefer people do things that seem sensible. But I do like the idea of having some story at all.
Yeah. Yeah, I guess in my circles, you're known as something of a cautious optimist about how well integration of super advanced AI into our world is going to go. I guess, all things considered, what do you think is the probability that humanity benefits from the advancement of AI as opposed to ends up worse off because of it?
Yeah, so continuing the theme from before, I'm just like, very uncertain. And it's especially because you asked such a broad question. Like, this isn't just misalignment. It's got misuse and structural risks, too. And there are, like, so many different categories within them. I don't know. Mostly I'm just, like, shrug, I don't know. Especially when you include misuse and structural risks, my opinions tend to vary wildly from day to day. So maybe I'll set those aside and talk about misalignment in particular. I think even there, I'm like, man, I don't know. I feel like positions like more than 1% and less than 50% all feel pretty justifiable to me.
This is of things going badly.
Of things going badly. And like, I don't know. I think I've given more consistent numbers than that when asked this question in the past, but also I think that's because I get asked this question so much that the numbers I give are just sort of like just completely anchored in my brain. I just repeat them all the time rather than actually like giving independent estimates. So mostly I just want to say like, nobody knows. We will get more evidence about this as time goes on as we build actually like quite powerful AI systems, and we can see what sorts of things happen with them. But right now, I just don't feel like every number is going to be made up, but these numbers feel particularly made up.
You wrote this nice post online not that long ago pointing out three general observations about the world that should make us each of them tiny but a little bit more optimistic about our chances of things going well. The first of them was that people seem a bit muddle-headed in general and not super goal-orientated. Why is that a hopeful thing in this case?
Yeah, so maybe I want to just have the disclaimer that, like most conceptual arguments, I don't think this should actually move people very much. And like this was like a comment I wrote in the space of probably less than an hour when someone had asked, well, what things could you have observed that would have made you even more doomy? But for this one in particular, so we talked a little bit about how the case for doom goes through these convergent instrumental subgoals. And I'm just like, okay, well, if we look at humans aren't that great at pursuing convergent instrumental subgoals. I think my favorite example of this comes from, I think it was a Scott Alexander piece where he talks about how his, I think, classmates in medical school, maybe, on a multiple choice exam, you could just easily calculate that the expected value of like guessing an answer, even given no information, was positive. And I think Scott like made this argument to the other students taking this medical exam. And like, the medical exam is pretty important to these students. They really do want to get a good score on this. And he's like, look, if you don't know, just guess. The EV is positive. And they were just not persuaded. They did not, in fact, then guess on this test. And I'm like, man, that's like such a clear example of like clearly intelligent beings humans in this case, but like probably this could also apply to AIs, not actually doing a thing that seems very clearly like a good convergent instrumental subgoal for them.
I'm not sure I'd want any of these people as physicians. Do you have any idea? I guess I don't want to get too caught on this specific example because you could have chosen plenty of other things. But do you have? I mean, I was told at high school, obviously, if you don't know the answer on an exam, on a multiple choice question, just definitely fill in one of the squares or tick one of the boxes because you got a 1 in 4 chance or 1 in 5 chance of getting it right. What's going on? I guess you went there, so yeah.
So I wish I had found and read up on this example before coming here, but I think to be fair to them, that guessing incorrectly did give you negative points. So it wasn't no downside.
I see.
But it was in expectation still the right call. And because you're doing this for many questions, it's with relatively high certainty you will tend to get a higher score. So I still think it's not that reasonable.
Yeah.
But you can understand their perspective a little bit more. As to whether you trust them as physicians, I don't know. I think mostly my perspective on this is man, it turns out that people aren't that quote unquote rational. But
and yet the world is as
the
it
world
is.
still works, Or well, I don't know if you maybe that's a controversial statement, but the world continues to be the way that you observed it to be in the past, which does involve some functional things, some dysfunctional things, but the fact that physicians don't seem all that rational, it's probably swamped by all the other evidence you have by just going around and looking at the world and interacting with physicians at other times.
Right. So anyway, the broader point is that humans are general intelligences that do have goals to a degree, and we've emerged through evolution and then also through our own experience, our brain adapting over time to its environment. And yet we are not monomaniacal optimizers that always make these great decisions and reason things through and get the absolute most out of life. We're actually often just acting on instinct.
Yeah, exactly. I'm I don't know. Has anyone who's not been steeped in the AI risk literature thought, aha, I have a bunch of goals. I should gain a bunch of power and try to take over the world in order to do this. And you might be okay, well, that's not all that reasonable. Most people can't take over the world even if they don't want to, so it's reasonable for them to not think about that. But I'm still I don't know, man. Humans just don't really think about just gaining a bunch more power and resources very much. Some people do, but not all of them. And it really feels like if you wanted to be really confident in doom, you should maybe expect that really all of the humans would be trying to optimize for power and resources.
Because that would indicate that most processes end up producing these monomaniacal optimizers, whereas in fact we see that that it is possible not to. Indeed, maybe it's even typical not to, at least through the process that generates humans.
At least up to the capability level that humans represent, yeah. I'm a little bit more sympathetic to once you get going around tiling the universe with something levels of capability where you've invented all of the technology by yourself. I'm okay, maybe by then that entity has to be pretty rational, perhaps. So I'm a little bit more sympathetic at that point. But I don't it's not clear to me that the argument goes through if we're only talking about that level of super intelligence being monomaniacal and goal-directed.
Because there'll be intermediate steps where you might have a more human-like agent.
That's right. And you can just sort of build this increasing, you can just sort of as you've got these intermediate AI systems that are still way better than humans at many things. They can help do better alignment research. They can help with assisting and supervising the next generation of AI systems and so on. Mostly I'm just once you've retreated to that point, I'm oh man, now things have gotten a lot more complicated and it's way harder to forecast what the future holds. And once again, you should just be pulled towards vast uncertainty.
Yeah. Okay, yeah, the second point the second observation you made is that planes don't crash and we do have labor unions. How is that a positive sign?
I love the way that you're phrasing these. So the broader point there was that humans do in fact sometimes coordinate to do things, including safety things, in the case of planes not crashing. Because I think part of the argument for one thing that often makes people very doomy is just thinking that humanity won't have its act together and will just rush full steam ahead to build powerful AI systems as fast as possible without any coordination between anyone. That's probably I think that's more extreme than people actually mean, but something along those lines is often a common talking point. And I think it's not that obvious that will be the case. It seems our society is actually fairly risk averse to me in general. In most places, I tend to wish our society would be less risk averse and do more things. And so I'm like, well, we do actually coordinate on avoiding risks in particular reasonably often. That could happen here too. How likely is it? I don't really know, but like it sure seems more hopeful than it could have been.
Yeah. I was reading some commentary on this from just random people on, I think it was Hacker News and Reddit yesterday on exactly this theme of whether you could get any coordination to make AI go better. And it seemed like most people who were commenting anyway were exceedingly skeptical that like any coordination at all would be possible. They were just like sneering at the idea, being like, well, if one group didn't do it, then there's 100 other people who would do the dangerous thing. And, if the US doesn't do it, then I'm sure China will just do it tomorrow. And I think this is, I guess, I don't know, shouldn't be personal, but I feel like this is a midwit position where people are coming in with this preconception about how the world works without actually knowing very much about the specific actors here. And in reality, currently, we really only have a couple of organizations that are capable of doing really cutting-edge model training. Many of them are actually quite receptive to doing coordination-related things. The other actors are substantially behind and probably also could be cajoled or coerced by a government into not doing the dangerous things. So while if someone was saying, we probably couldn't hold back we probably couldn't prevent the dam from collapsing forever, I think, okay, probably that's right. But if you're just trying to delay things somewhat by months or years, I think you'd have a good shot at doing that with so few actors that are generally quite cordial and open to the idea of being more gradual.
Yeah, I think that's right. So I think that I have, historically, not so much anymore, but historically been a much more modest in the like EA rationalist sense kind of person, where I'm like, what special reason do I have for thinking that I'm right? Surely all these other people have thought about things a lot more than me, have, good reasons for their beliefs, and probably I should think they're right. But then I also like look at people, I'm like, surely that can't be right. And this is a good example of one of those things. And now I've moved to DeepMind and I have actual views. I can actually see what DeepMind as a whole thinks. I'm like, yep, that's just totally wrong. Inaccurate predictions all the time. In fact, people just often confidently say things that are wrong. And I should just not actually be all that modest. I think my favorite example of this is like, I saw a comment that was like the FLI open letter that came out yesterday asking for pausing giant AI experiments. This person's position was that like probably this was done by all of the labs that were not OpenAI so that they could stop OpenAI from training GPT-5. And I'm just like, that's clearly not true.
Yeah.
It's obviously just the FLI wanted to do this because that's what the FLI has wanted to do forever. And FLI is the one who like coordinated everything.
Right. Yeah, exactly. Yes, I've seen this cynical take as well. And I suppose, at least in my case, I'm slightly cherry picking here because I'm just talking about random commenters on Twitter or on Reddit or on Hacker News, who I think by and large have only learned that this is an issue at all in the last few days or weeks. And they're kind of just coming in with, priors with a particular worldview through which they're guessing what is going on. And I suppose having a cynical take that, who would be most likely to want to slow things down? I guess it would be the people who are behind right now. It's not a crazy hypothesis, but I also just know that it's completely false in this case. I'm just like, I have no doubt about it. It's like, it's got nothing to do with that, basically. I don't know. Maybe some out of the 1,000 people who signed it had some motivation like that, but
sure.
That's not the reason why this letter exists. The people who signed it have had the same opinion for like 10 years in many cases. They've been waiting for a chance to sign some letter like this.
Yeah, I think I'm just like, kind of shocked at the like sheer confidence with which people say these things.
Yeah.
And it's something that I, would have told like teenage Rohin. No, people are just like very frequently extremely confidently wrong. Turns out that's just how humans work.
Yeah. I suppose there's probably plenty of people who didn't have a strong take and they just didn't leave comments or they didn't speak up about it. But
this is true.
Yeah. Okay, the third point, though, the third observation you made was that universities have, as it turns out, specific majors in particular subjects rather than just teaching all students to be smarter. Yeah, what's hopeful about that?
Yeah, so I think there's a question of whether it is generally good to have specialization of labor versus just having like one generally intelligent system that does everything. I don't think the case with humans is necessarily a ton of evidence for the case with AI systems, because humans also have this constraint that our brains cannot become that big. You cannot just arbitrarily scale up our brains, whereas you basically can just arbitrarily scale up the size of neural networks. But nonetheless, I think it is relevant in the sense that like this should update you a really tiny bit, like all of these other conceptual arguments, that with humans, we do in fact do a lot of specialization of labor rather than trying to do one sort of like, you're trying to create a bunch of like generally intelligent humans and then point them at particular problems as necessary. And like the universities thing was one thing that was, meant to capture this overall point. Now, why is that a reason for optimism? Well, I think it's just a lot easier to imagine a monomaniacal goal-directed AI system if it was sort of like this very general thing that was being applied across a wide variety of tasks. Whereas if you have AI systems that are like doing a bunch of specialized things, you would maybe expect that they're more circumscribed in those tasks and not trying to do this thing of taking over the world. So that's one thing. I'm not sure how much I believe that, but like that's one thing. You would still be worried about the system of many specialized systems as a whole overall implementing via communication between all of them some sort of goal-directed, some sort of emergent goal-directed reasoning. And so that's a way you could be worried. But like, I don't know, it just feels intuitively a bit less likely to me. And also, you could hope to then like look at the actual communication between the AI systems and supervise that. And so that gives you an avenue of attack where you can try to apply alignment techniques that leverage that fact, which you maybe couldn't do for the more general systems.
Yeah. So the very general question here is it the case that you can just get better at many, many different kinds of tasks across many different, subjects of knowledge, all simultaneously by just gaining this quality of intelligence? Or is it the case that most knowledge is quite specialized, and if you want to be really good at chemistry, you can't just become smarter. Instead, you have to actually study. You have to like study within that particular domain, and then the things that you learn about chemistry are not really going to transfer over very much to other areas. I guess I actually don't really know where the balance lies between. You look like a little bit like maybe I've put this incorrectly. Would you put things differently?
I think I'm like I like directionally agree with that, but I wouldn't phrase it as a can you do better with more intelligence. I think there are certainly going to be some domain general techniques that do improve performance. The question is sort of like, which one do you get more marginal benefit for? Like, I certainly believe that there are domain general like reasoning techniques that will help you across a wide variety of fields. But maybe in practice, you're just like, well, I could invest in that, and that would give me 1 percentage point of improvement. Or I could just do the specialized thing, and that gives me 20 percentage points of improvement. And in that case, you'd still want to do the specialized thing. So I would put it a little bit more quantitatively like that.
I see. Okay. So even if one could invest an enormous amount of resources in becoming just generally better at thinking and learning across the board, you need to think about, well, the relative return of training in these different things. And you might hit diminishing returns on the general thing, and then it becomes way better to specialize in most cases.
Yeah, that's right.
Okay. I mean, I've heard some people say that one reason why they're not really worried about AI massively transforming things is basically that they think that this general quality of intelligence is not so important. And in fact, most things that we accomplish, we do through highly specialized knowledge. On the other hand, I mean, wouldn't you be worried about us just training models that are better at like all of these specialized tasks and all of these specialized areas of knowledge? And then, as you're saying, kind of then collectively, it's a generally intelligent machine just with lots of highly specialized trained subcomponents on each different kind of activity or each different domain of knowledge.
Yeah.
Okay.
I agree. You should definitely be worried about that. And that's what, like, if I were more confident that that's what the future would look like, maybe I would be spending more of my time thinking about what alignment looks in a world like that. I think right now I'm just like, let's figure out what to do with neural networks. That seems like a good current problem to focus on, but plausibly in the future, alignment research ends up focusing on that situation instead. I do think it's something you would want to worry about. And even like the main person who's talked about this sort of scenario, Eric Drexler and comprehensive AI services, his position is not that comprehensive AI services are safe. His position is they have different risks than the, one godlike superintelligence AI systems.
It seems like GPT-4 has, it's capable across a wider range of domains than I might have expected just from studying a whole lot of text. It feels like there is some general thing going on there. I don't know whether you'd call it general intelligence. I'm not sure. But yeah, does that speak at all to this question of specialization versus generalization?
Yeah, it's a good question. I would say that GPT-4 is clearly way better than humans at just like knowing things that people have said and being able to like use that knowledge and at least some extent. So I'm most reminded of Brian Kaplan's bet. I don't know if you've seen this. Brian Kaplan had a bet with Matthew Barnett about whether a future AI system would be able to get an A on some number of his midterms. And I think the bet was like all the way out until 2029 or something. And GPT-4 did get an A on his most recent midterm. But like, if you look at the questions and how Brian graded them, in some of them at least, it's like, what did X person say in response to Y argument? And GPT-4 says the answer. And Brian's note is like 10 out of 10. That's exactly what that person said. And I'm like, yep, that sure is the sort of thing that a large language model would be really good at. So I think it gets a lot of generality across a wide variety of domains by just having all of this knowledge. It's got just way better memory and knowledge than humans. It's less obvious to me, but might still be true, that this translates into really good capabilities across the board, even when you're like, say, trying to develop new knowledge in all of these domains, which feels like the capability I'm looking at most.
Yeah. Has Brian finally lost one of his bets? He's been on the show before and we've talked about how he's made an awful lot of predictions about the future. And I think he had a record of winning 20 of his bets in a row.
He's not actually lost it yet. But
why's that? Sounded like he had.
I think the bet was technically about an AI system getting an A on like the past 5 or 6 midterms or something like that, but only one has been tested. I don't know the exact details.
Got it.
But he hasn't conceded just yet, but I think he does expect to lose.
Okay, yeah, it makes sense. If ML researchers can deal with the technical aspect of figuring out how one could build a safe AI agent in principle, how far do you think that gets us towards a future in which AI does actually end up being clearly beneficial?
Yeah, so I think there are like 2 ways in which this could fail to be enough. One is just, again, the misuse and structural risks that we talked about before. Great power war, authoritarianism, value lock-in, et cetera, lots of other things. And I'm mostly going to set that to the side. Another thing that maybe isn't enough, another way that you could fail if you had done this, is that maybe the people who are actually building the powerful AI systems don't end up using the solution you've come up with. And partly I think I want to push back against this notion of a solution. Like, I don't really expect to see a clear technique backed by a like proof level guarantee that like if you just use this technique, then your AI systems will do what their designers intended them to do, let alone produce beneficial outcomes for the world, even just that. Like, if I expected to get a technique that really got that sort of proof level guarantee, I'd feel pretty good about being able to get everyone to use that technique, assuming it was, not incredibly costly.
But that probably won't be how it goes.
Yeah, mostly I just expect it will be pretty messy. There'll be a lot of public discourse. A lot of it will be terrible. Even amongst the experts who spend all of their time on this, there'll be a lot of disagreement on what exactly is the right thing to do, what even are the problems to be working on, which techniques work the best, and so on and so forth. And so I think it's just actually reasonably plausible that like some AI lab that builds a like really powerful, potentially X-risky system ends up using some technique or strategy for aligning AI where like if they had just asked the right people, those people could have said, no, actually, that's not the way you should do it. You should use this other technique. It's Pareto better. It's like cheaper for you to run. Yeah, it's cheaper for you to run. It will do a better job of finding the problems. It will be more likely to produce an aligned AI system, etc. I'm like, it seems plausible to me that like when I tell that story, I'm like, yeah, that does sound like a sort of thing that could happen. And so as a result, I often think of this separate problem of like, how do you ensure that the people who are building the most powerful AI systems are also getting the best technical advice on how they should be aligning their systems, or are the people who know the most about how to align their systems. And in fact, this is where I expect most of my impact to come from, is advising some AGI lab, probably DeepMind, on what the best way is to align their AI systems.
I see. So the basic story here would be, you could imagine a future in which some group has published a great paper on an approach that, in fact, would work if it was adopted, but people don't realize that this actually is the best way forward, and they adopt some other approach, or the relevant decision makers pick some other approach for making things, for trying to align their systems, and that one doesn't work out. So you not only have to have the right approach on the book somewhere, but you also have to pick it rather than a different one.
Yeah, that's right. And I think even like maybe the thing that feels a little bit less likely about your story is that you mentioned that it was in a paper. And I'm like, nah, it won't even be in a paper. It'll be a bunch of like implicit knowledge that people have built up by just like doing a lot of practice work ahead of time. And it'll be like small little details, like you should make sure that when you're giving instructions to your human raters, you follow such and such principle because that works better. Or when you're asking your AI systems to give critiques, make sure you use this particular trick for your prompt because that works better, and so on. Stuff that like is implicit knowledge amongst practitioners, but it's not like you could have just read one paper and known to do that.
Yeah.
Or like, actually, when you're aligning your AI systems, you should put like 5x as much time into or effort into red teaming the model as you are in like doing interpretability into the model, because empirically that's worked out best in the past. Things like that.
So what does this imply about what people ought to do? I guess it means that there's a lot of value in being in management or advisory roles where you might be tasked with making this kind of decision.
Yeah, I think that's right. But I would also want to emphasize that like if you are going to be in that role, you also then need to be like the most technically competent person,
right?
Or at least better than whoever your replacement would have been. So I do want to make sure that like if people are trying to follow this path, they're also seeing it as a priority to like really be on the ball about technical alignment. And like, so I've actually not been that good about this over the last year or two, which would be a much bigger failing if we were on the cusp of building, X-Swirsky systems, but we're not, so I can still catch up. But in fact, over the course of my career, I've been really trying to just like always be very on the ball about what's going on in alignment, what things are best, having opinions about, if we had to do something today, what would we do, and things like that. And then separately from that, also trying to be in more of a senior position at DeepMind where I would in fact have the ability to advise the AGI projects on what they should be doing.
What are the main barriers to getting more cooperation and I guess ideally active collaboration between different AI labs? I guess in particular with the goal of avoiding them feeling like they have to rush to deploy technology before they really feel fully comfortable with it, because otherwise they're going to lose market share or be irrelevant.
Yeah. So you would like the labs to ideally like do like safety research together. There, I think one of the bigger blockers is just for clear and obvious reasons. I think all of the AI labs will want to keep their IP confidential. And it just really, when you're doing safety research, it really does help to just be able to talk about the specific results and numbers that you're getting from your largest models for at least many of the kinds of safety research that labs tend to do. And that's something where it's just like, well, you can't share that by default because it could actually leak some IP. With enough review, you could do some of the things, but probably not all of the things. And this just also becomes high friction, and in some cases just not actually feasible. So that's another bottleneck that I don't really know what to do about. But there's also just things like talk to each other about what the overall alignment plan should be. What would we do if, at a high level, if we had to align an AGI today? And that sort of thing seems great. And individual safety researchers at the labs often talk to each other about this sort of thing.
Why can't you have an agreement between, I guess, hypothetically, OpenAI and DeepMind, where they both say we're going to share our intellectual property with one another because we think it's in both of our interests? I mean, it could be in both parties' interests commercially, as well as like even setting aside any safety issues.
I think in theory that sort of thing is actually plausible. This sort of institutional work is more the wheelhouse of the strategy and governance team at DeepMind. So I don't actually know that much about it, but I know this is the sort of thing that they've been thinking about, though possibly the way they've been thinking about it is nope, this is definitely not feasible for this obvious reason. Okay. I'm not sure that I would know. I think you are going to interview some of them in the near future, so hopefully you can ask them about that.
Will do. If people in the ML community decided where to work, in part based on which companies they perceived to be acting most responsibly in which ML systems they were training and how they were testing them, and then when and how they were deploying them, how much do you think that could avoid competitive pressures, kind of creating a sort of race to the bottom where everyone feels like they have to rush things out the door?
I generally like this sort of like race to the top on safety type dynamic. It does seem pretty great. And I do think this could actually have a fairly big impact. Like, it really is just one of the top priorities for AGI labs is, in fact, just making sure that they can attract and retain talented ML folks. And so to the extent that the talented ML folks are like, I would like to know what you're doing about fairness and bias or whatever, or alignment or disinformation. And then like their decisions actually depend on what the company's answers are to that. I suspect that would make the companies, the AGI labs, at least care more about communicating the sorts of things that they're doing. I think you're already seeing that to some extent now with various public statements by AGI labs about their views on AGI safety. And yeah, overall, it seems like a pretty good thing to me. It is important, though, that the people who are making decisions on this basis are like making it on some basis that actually correlates with being responsible as opposed to some sort of proxy that then gets good-hearted.
I guess you're saying people could write really nice pieces or, they'd put safety in the name or safety in the slogan, but then it doesn't necessarily translate into any actual behavior. Or is that the worry?
That's like an example of how that worry could cash out, yeah.
Yeah. I guess the key question there would be, can people tell the difference, or can the people who are considering where to work tell whether it's just empty words or whether that really reflects the values of the organization?
Yeah, so one of the things I was talking about with some folks earlier who are more external to the labs is that like I really would love it if there was just a nice, robust research area outside of the labs that was just talking about what are the properties that we would like the AGI labs to have, and how could we then verify that they actually satisfied these properties, in part to enable this sort of race to the top on safety. Often I end up telling people like, yeah, for many kinds of research, it's quite good to be at an industry lab or one of the few nonprofits that are doing research on deep learning systems. But this is an example where it's actively good to not be at a lab, because if you're at a lab, then anything you write is sort of like, well, you have a little bit of a conflict of interest. Are you worried that like maybe you chose this particular property because your particular lab is really good at this, but everyone else isn't? So this is a place where I think independent people have the opportunity to shine.
Yeah. Sounds like we need something like the Wirecutter, but for which AI lab should you go and work at if you're one of the top ML researchers?
Yeah, seems great.
Even in a case where all of this goes super well, it feels like the end game that we're envisaging is a world where there are millions or billions of beings on the Earth that are way smarter and more capable than any human being. Lately, I have kind of begun to envisage these creatures as demigods. I think maybe just because I've been reading this recently released book narrated by Stephen Fry of like all of the stories from Greek mythology. But I guess in practice, these beings would be much more physically and mentally powerful than any individual person, and these minds would be distributed around the world. And so, in a sense, they can be in many places at once, and they can successfully resist being turned off if they don't want to be. And I guess they could, in theory, like the gods in these Greek myths regularly do, just go and kind of kill someone as part of accomplishing some other random goal that has nothing in particular to do with them, just because they don't particularly concern themselves with human affairs. Why isn't that sort of vision of the future just pretty terrifying by default?
Yeah, I think that vision should be pretty terrifying, because in this vision, you've got these godlike creatures that just go around killing humans. Seems pretty bad. I don't think you want the humans to be killed.
Yeah.
But maybe the thing I would say is, like, ultimately, this really feels like it turns on how well you succeeded at alignment. If you instead say basically everything you said, but you remove the part about killing humans, just like there are millions or billions of beings that are way smarter, more capable, etc., then I'm like, this is actually kind of sort of the situation that children are in today, in that there are lots of adults around. The adults are way more capable, way more physically powerful, way more intelligent. There are lots of them. They definitely could kill the children if they wanted to. Well, but they don't, because in fact, the adults are at least somewhat aligned with the interests of children, at least to the point of, like, not killing them, and the children aren't, like, particularly worried about the adults going around and killing them, because they've just sort of, like, existed in a world where the adults are in fact not going to kill them. And all that empirical experience is, like, really just trained them to be like, yeah, the world is... Yeah, this isn't true for all children, but at least for some children, they've been trained to believe that the world is, like, mostly safe. And so they can be pretty happy and function in this world, even where they do not, in principle, somebody could just make their life pretty bad, but it doesn't in fact actually happen. And similarly, I think that if we succeed at alignment, probably that sort of thing is going to happen with us as well, as we'll go through this, like, roller coaster of a ride as the future gets increasingly more crazy. But then we'll get sort of pretty quickly, I would guess, acclimated to this sense of, like, well, most of the things are being done by AI systems. They generally just make your life better. Things are just going better than they used to be. It's all pretty fine. I mostly think that once the experience actually happens, and again, assuming that we succeed at alignment, then people will probably be pretty okay with it. But I think it's still, in some sense, kind of terrifying from the perspective now, because we're just not that used to, like, being able to update on experiences that we expect to have in the future before we've actually had them.
Yeah. Yeah, I guess maybe one reason why this sounds extremely unnerving as a situation is that as adults, the situation in which we would be as powerless as that, I guess, is one where we're being held in prison or we're slaves or something like that. Well, with children, you're giving a case where you have other beings that are outnumbered and are outpowered, but aren't in prison or aren't being treated horribly. And that's a situation that we could hope for in future. I mean, I think many people... I guess it's interesting. Some people just might not want this to happen, or they might not like this future at all. I mean, I guess personally, I think, for better or worse, basically all of the best features involve some transformation of this kind. And so even though I do find it unnerving, it's not something that I want to prevent per se. But I guess if you're just someone who says, this is not what I want, I would like the world to stay more like it is now, what could you say to someone like that? I suppose, unfortunately, it's just going to be too hard to stop.
Yeah, that, I don't know. Maybe I would still dispute the premise. Like, I gave the example of children because it's a little clearer, but even with adults, I'm not actually sure that the argument changes that much. There are still a bunch of things like the police, for example, who in theory could kill you. And in fact, for some adults, that is in fact just a worry that they have frequently, but not, say, you or I. And so, like, the fact that there exist other agents that in theory could have power over you is in fact kind of frightening when you actually sit and meditate upon it. But I think not actually that frightening when you are living through it, as long as they don't actually exercise that power. And mostly I just observe that, like, people live lives today that in theory could be disrupted fairly easily by a variety of people or groups. And this doesn't actually bother them that much. And so probably the same will be true in the future.
Yeah. Okay. Pulling together a couple of the different threads that we've talked about, I guess it sounds like we don't know how hard this problem is, and it's going to be hard to tell whether we've got a good solution to it, even if we in fact do have one. Given that, would it be sensible to slow down advances in what ML models are capable of doing and which models are deployed publicly, so that we have more time for everyone, including DeepMind and OpenAI and everyone else who's working on this issue, to learn how the current models work and do additional safety testing and figure out how best to govern and test future even larger, more capable models?
Yeah, I think I would be generally in favor of the entire world slowing down on AI progress if we could somehow enforce that that was the thing that would actually happen. It's less clear whether any individual actor should slow down their AI progress, but I'm broadly in favor of like the entire world slowing down.
Yeah. Is that something that you find plenty of your colleagues are sympathetic to as well?
Yeah, I would say that there, like, DeepMind isn't a unified whole. There's a bunch of diversity in opinion, but there are definitely a lot of colleagues, including not ones who are like, working on specifically X-risk focused teams who believe the same thing. I think it's just, you see the world you see the AI world in particular getting kind of crazy over the last few months. And it's not hard to imagine that maybe we should slow down a bit and try and take stock and get a little bit better before we advance even further.
Yeah. It does seem like more and more people are getting sympathetic to that kind of agenda. You mentioned earlier that, there was this open letter that came out just yesterday. I guess, it was coordinated by the Future of Life Institute, but had over 1,000 signatories yesterday. And I suppose probably we can expect there to be substantially more. Its heading was Pause Giant AI Experiments. And it had some of the people you might really expect to be on there, including ML researchers like Joshua Bengio and Stuart Russell and Steve Alejandro, as well as other people, other non-ML people who've spoken about their AI-related concerns, like Elon Musk and Tristan Harris. But some of the other people on there surprised me a bit more. There was Steve Wozniak, the co-founder of Apple. I'm not sure how you pronounce it, but Emad Mostak, the CEO of Stability AI. I think they was doing image generation AI models, right? And made a big splash.
That's definitely one of the things they've done.
Yeah. There was also Gary Marcus, who's an AI researcher who, in general, has been extremely skeptical that any of the things that any of the AI models that we're developing right now are going to develop into artificial general intelligences. He thinks we're missing lots of important insights, but nonetheless, he signed this letter. I might actually just read a little bit of it for people who, because I imagine plenty of people in the audience might not have actually gotten to that. Yeah, maybe a key section would be contemporary AI systems are now becoming human competitive at general tasks, and we have to ask ourselves, should we let machines flood our information channels with propaganda and untruth? Should we automate away all the jobs, including the fulfilling ones? Should we develop non-human minds that might eventually outnumber, outsmart, obsolete, and replace us? Should we risk loss of control of our civilization? Such decisions must not be delegated to unelected tech leaders. Powerful AI systems should be developed only once we are confident that their effects will be positive and their risks will be manageable. This confidence must be well justified and increase with the magnitude of a system's potential effects. OpenAI's recent statement regarding artificial general intelligence states that at some point it may be important to get independent review before starting to train future systems, and for the most advanced efforts to agree to limit the rate of growth of compute used for creating new models. We agree. That point is now. Therefore, we call on all AI labs to immediately pause for at least 6 months the training of AI systems more powerful than GPT-4. This pause should be public and verifiable and include all key actors. If such a pause cannot be enacted quickly, government should step in and institute a moratorium. This is pretty strong language.
Yeah.
And I think I haven't been following it on social media, and I think the reaction has been mixed. But the fact that something this strong can be splitting people quite a bit is kind of interesting. The letter suggests not doing training runs that involve more compute than that was required to train GPT-4. If you thought that slowing down of some form I guess it sounds like you think it probably is desirable. Is that a sensible target to use, or a sensible kind of rule of thumb to use to figure out whether things are dangerous?
So I'll note that the open letter just said more powerful than GPT-4. I don't think it mentioned compute.
Okay,
but,
my bad.
I do think that compute is actually a pretty good proxy to use, at least right now, and at least if you're only considering a 6-month timeline. If you were thinking about longer than 6 months, if you were imagining like 5 years or something like that, which, to be clear, I'm not sure that I would endorse, but if you were thinking about something like that, then you would also want to account for the improvements in algorithmic efficiency, training efficiency, and so on that people will inevitably discover in that time. And so maybe you would just say, no, it's fine. That's like a relatively slow enough growth that it's okay if people use that to make better models. Or maybe you'll be like, actually, the amount of compute you're allowed to use shrinks over time.
I see. Okay, yeah. So it sounds like compute used in training is a reasonable proxy. But of course, it's a moving target because we'll get better at making that compute count for something. And so potentially, I guess in theory, if you wanted to make sure that no one developed a model that was more impressive than GPT-4, you'd have to reduce the amount of compute to reverse that effect, more or less.
Yeah, that's right.
And I guess as there's more compute available more broadly, the number of actors that could, in principle, do a training run larger than that would grow. And so you'd have to get more people on board, or I guess do more monitoring and as the years went by.
Yeah, absolutely. I believe actually Yonadev Shavet has a paper about this recently. I haven't read it yet, but I remember chatting to him about it and thought that was quite interesting. So if people want to check out how, in fact, something like this could be enforced, that's a paper to read.
Yeah. Yeah. Do you have a broader reaction to the letter? I suppose it sounds like you're sympathetic to the general goal that, if we could coordinate to make things go more gradually, that would be good. But do you have any comments on the tone of it?
Yeah, I think I agree with the general vibe, which I would characterize as
freaking
something, maybe not that exactly. I would have said things are moving at a breakneck pace. We need to actually spend some time orienting to the situation, dealing with it, and getting into place some sort of safety measures. As a result, in order to do that, we need to actually stop the breakneck pace for a while, and hence the pause.
Yeah.
And I think that vibe I am broadly on board with. Then there's a bunch of specifics where I'm I don't know that I would necessarily agree with that in particular. One of them is this pause training models as powerful as GPT-4. I'm who even knows what as powerful as GPT-4 means? When you say something like compute, then that's at least a little bit more clear. I'm not actually sure if it's known how much compute GPT-4 used, but if it is, then that would be a real target. Anyway, there's more disagreements like that, but I don't know. I feel like the point of open letters is often the vibe they present, and when people sign it, they're more just saying, I agree with this general vibe, if not necessarily every single sentence, and I'm mostly on board, I think.
Yeah, it's interesting that I read in the compute thing, I guess because I was reading between the lines, and maybe I'd heard that idea before, so I was inclined to perceive it that way. But yeah, it is just more general than that. What's the most powerful argument against adopting the vibe of this letter? Yeah,
so one of the things that's particularly important for safety research, at least some kinds of safety research, is to be working with the most capable models that you have. Because, for example, if you're using the AI models to provide critiques of each other's outputs, they'll give better critiques if they're more capable, and that enables your research to go faster. Or you could try making proofs of concept where you try to actually make one of your most powerful AI systems misaligned in a simulated world, so that you have an example of what misalignment looks like that you can study. And that, again, gets easier the more you have more capable systems. And so there's this resource of, capabilities adjusted safety time that you care about. And it's plausible that the effect of this open letter, again, I'm only saying plausible, not saying that this will be the effect, but it's plausible that the effect of a pause would be to decrease the amount of time that we have with, some things one step above GPT-4. Without actually increasing the amount of time until AGI or powerful AI systems that pose an X risk, because all of the things that drive progress towards that, hardware progress, algorithmic efficiency, willingness for people to pay money, and so on, those might all just keep marching along during the pause. And those are the things that determine when powerful X risky systems come. And so on this view, you haven't actually changed the time to powerful AI systems, but you have gotten rid of some of the time that people could have, that safety researchers could have had with the next thing after GPT-4.
I see. Yeah, I think this is, or Sam Altman has been making an argument of this kind. Sam Altman's the CEO, I think, of OpenAI, where I think he's pointed out that, if you do something like this pause right now for 6 months, then in the next 6 months, then we don't have access to GPT-5, say, so we can't study that. And then if nothing else has changed other than we've had this letter and then the pause and then the moratorium ends, then you get the sudden jump, basically, because, all of the compute and the other research has been continuing at pace in the meantime. So his sort of argument is that we need to allow things to go faster now so that they go slower later on, or something along those lines. Maybe I'm not getting it right. How would you put it?
That's probably what he said. I feel like I disagree more with that version of the argument. I do feel like and also the time to like the actually X risky systems didn't change is like pretty crucial to my argument before. I do agree that you probably get some amount of jump from people continuing to do research and building some amount of overhang over those 6 months. But I don't think it's actually that big. And I do think that it does meaningfully increase the like delay until you get the next generation of systems. And I'm like, probably I just think that if that were the only consideration you were thinking of, I just would take the delay, even though it has a like tiny little overhang. Partly, I just don't think the overhangs from 6 months are very high.
I see. Yeah. I suppose the gain over that time period is also not so high because it's just not very long.
Sure.
Yes. I was reporting what someone else told me Sam Altman had been saying. So I should at some point go back and listen to the original interview and fully understand the view. And then I guess I'll talk about it in a future interview with someone else. I suppose in general, I recoil from arguments that say, although it would be good to go slow in general, we shouldn't go slowly now because that will cause things to go faster later, because they have this kind of too cute by half or like overthinking the issue aspect to them, where I'm just like, if we think that it would be good for things to go slower, then we should try to make things go slower and not think about second order effects all that much, or at least the kind of the burden of proof would be on the other side. It sounds like you maybe feel a bit similarly.
Yeah, I think I broadly do agree. And I'll remind everyone that, in fact, my overall position is like, if the world could slow down right now, probably should, despite these arguments that I'm giving for why that might be bad. Where, I guess for me, I'm just, maybe the way I would justify this is there are always going to be a bunch of second order effects you didn't consider. So in this particular case, the second order effects we haven't considered are well, okay, if you just start slowing things down now, maybe that makes it easier to slow things down in the future. Seems like totally a thing that could happen, in which case, and if that were the dominant second order effect, then it seems like to the extent you were really bought into let's slow things down maximally, which to be clear, I'm not sure that I am. But if you were bought into that, then you would be pretty into just doing this open letter for that second order effect. And anyway, so overall, I do tend to agree with you that when you're getting this too cute by half sense, the way I would usually say that cashes out is an intuition that probably maybe this second order effect is true, but probably there are a bunch of other second order effects that go in the opposite direction, and probably we should just do the sensible common sense thing instead.
Yeah. At some point I'll get someone on the show who thinks that slowing down would be bad or neutral, so they can represent this view. It's maybe a little bit hard for us to fully steelman the position because neither of us holds it.
I'm I don't know, maybe I'm 20-30% on it.
Okay, yeah. So it's a plausible view. I
find it plausible, mostly for the argument that I gave before, and also the overhangs argument. I don't find it compelling over 6 months, but I do find it compelling if you were 20 years.
Yeah. I guess a question from the audience is, there's been a lot more public discourse about risks from AI recently, mostly involving people taking risks more seriously. I'm interested in Rohin's general take on the discourse, but one particular question is, how valuable is non-experts thinking that the risks are real?
So I think there's definitely a decent bit of value in having non-experts think that the risks are real. One is that it can build a political will for things like this FLI open letter, but also maybe in the future things like government regulation, should that be a good idea. So that's one thing. I think also there's just people's beliefs depend on the environment that they're in and what other people around them are saying. I think this will be also true for ML researchers or people who could just actually work on the technical problem. And to the extent that a mainstream position in the broader world is that ML could in fact be risky, and this is for non-crazy reasons. I don't know, maybe it will be for crazy reasons, but to the extent it's for non-crazy reasons, I think plausibly that could also just end up leading to a bunch of other people being convinced who can more directly contribute to the problem. Yeah. So that's about just talking about it. Of course, people can take more direct action as well.
Yeah, is there anything, like, if you're someone who's not super well informed, but you're generally troubled by all of this, is there anything that you would suggest that someone in that position do or not do?
Yeah, I unfortunately don't have great concrete advice here. There's like various stuff like advocacy and activism, which I'm a little bit skeptical of. I'm a little bit worried that mostly I'm worried that the issues are actually pretty nuanced and subtle, and it's very easy for people to be wrong, including the people who are working full-time on it. And this just seems like a bad fit for activism, at least, and probably advocacy, too.
Yeah.
So I tend to be a little more bearish on that from people who are, not spending that much time on thinking about it. There's, of course, the sort of obvious, normal classic of just donate money to nonprofits that are trying to do work on this problem, which is something that maybe not anyone can do, but a lot of listeners I expect will be able to do. But yeah, I do wish I had more things to suggest.
Well, it's not easy. I mean, I don't think this is an exceptional case where it's difficult for an amateur who doesn't have any particular training or any particular connections to make a difference on it.
Yeah.
That's true in many different areas.
Mm-hmm.
I suppose one recommendation might be try to become very knowledgeable about this topic and sit tight and wait for an opportunity to maybe apply that.
Oh yeah, absolutely. So there's definitely, if people are willing to put in a lot of time into this, then there's, I think, a lot more options for what they can do. Just understanding the arguments really well and being able to talk to people about them already seems like a great bar. You could learn a bit more of programming and machine learning to get a sense of what that's like in order to be able to speak that lingo as well. And probably this will end up being useful somehow. It's not totally obvious how, but I'd expect there will be opportunities to use that skill set in the future. I think one good example is or actually, this is just something people can do now, even, is just become really good at finessing AI models to do useful things. So things like prompt engineering, chain of thought, and so on.
One thing is, even if this isn't a great fit for advocacy and mass public campaigns, my guess is that it's more likely than not that many of the questions that we're talking about, or just the question of is AI improving things or making things worse, is going to become a live public issue that is discussed in the same way that many issues are discussed in politics, which is not always brilliantly. And just having many more people who are able to correct misconceptions and talk about things more sensibly, even if they're not the most cutting edge technical experts, is probably better than not having those folks.
Yeah, that's very fair.
Yeah, on a very related topic, I think I've heard you say that you think a lot of outreach or public discussion of risk associated with AI is overall probably harmful because it's not super precise, and it can, I guess, on the one hand, put people who understand the technology off of these arguments because what's being said is confused or wrong, or alternatively, it does persuade them, but then they end up with a confused idea of what the actual issues are because they haven't been communicated very well. Yeah, have I understood that right?
Yeah, I think that's right. I should note that I'm also very uncertain about this. And when I say overall harmful, I'm all right, maybe I think it's 60% likely to be negative and 40% likely to be positive, and kind of equal magnitudes on both sides. And so I'm all right, maybe that's overall harmful. But my opinion 2 years ago would have been 60% positive and 40% negative. I don't think it's a big swing. And I don't think people should take this as a super confident opinion on my side. But
I see.
Yes.
Yeah, and I guess that if that were right, the bottom line would just be that one needs to spend maybe much more time reading and learning about these things than talking. Or maybe you need to have a big ratio there where, you can spend 1 hour writing comments and saying things about this for every 10 hours that you spend doing coursework or reading other people's opinions and deeply understanding them. Or, is something along those lines right?
Yeah, something along those lines seems right. I would maybe focus more on getting to some bar of quality or something, and then just talking a bunch and rather than thinking about the ratio exactly. But yes, that seems overall correct to me.
Is there something about this argument that proves too much? Because it feels like it should imply that, in many technical areas, it's basically just bad for non-super experts to be talking about those topics and sharing their opinions or their hopes or fears about it. I mean, maybe that actually just is the case, but I guess I'm not sure that we always say this about other areas as well. Like, would we also say that it's extremely hard to have sensible opinions about foreign policy, so people who don't study it professionally should just not really comment on it? Yeah, I don't know. It just seems unclear whether that's true.
I think so a distinction I want to make is between people who are just sort of sharing their opinions on things versus people who are I'm going to go out and find the people who could work on foreign policy or AI alignment, in this case ML researchers, and I'm going to specifically try to persuade them that AI risk / opinion about foreign policy is a real thing, and then get them to do things. And it's more I think people sharing opinions is probably good and fine. It's more the deliberate targeting of specific people and then trying to convince them of particular arguments that leaves me a bit more worried. That being said, I do think that even in the foreign policy world, if you're what's the impact of someone who's not thought all that deeply about foreign policy sharing their opinions, I'm I don't know. No, probably to a first order approximation, it doesn't have an impact. But if it did, I wouldn't be shocked if it was negative.
I think I've also seen you write that you found that people writing about risks from artificial intelligence online, I guess even ones who kind of do this as something like their job, often explain things in a way that you think is technically wrong, or at least it wouldn't persuade you as someone who's really familiar with the technology. Yeah, where do you think, where are people falling down?
Yeah, so I think there are a few categories here. So I think probably the most common one is to say true statements that are actually just kind of weak and don't actually lead to the conclusions that people are usually taking them to imply. So one example along these lines is arguments well, neural networks are always going to make mistakes. There's always going to be failures of generalization. And I think there is a version of this argument that does actually make sense. But as I phrased it just now, I think that actually reasonable response to this is okay, let's not put neural networks in high stakes situations. We won't give them access to the launch all the nukes button. Sounds good. Solved. And so I don't think this leads you to and the most important thing to do is to work on alignment, which is usually what people are trying to argue for when they do this sort of thing. So that's one category of thing. The second category is arguments that are based on conceptual reasoning that don't survive the what about ChatGPT argument. So for example, in the past, well, actually, even now, sometimes people say things well, we don't really know how to express all of the things that we want or that we value. And so it seems likely that we'll fail to express something that we actually did care about. And then as a result, because value is fragile, the future will be valueless. It will be just very bad. And then I'm well, I don't know, man. If you look at ChatGPT, you can just ask it to do something, and it really just interprets your words in a fairly common sense way most of the time. And to the extent that it doesn't, it's usually in a way where you're oh, okay, silly ChatGPT, you just don't have this capability of doing arithmetic or whatever.
Yeah.
And so I think I'm well, if your main argument for focusing on AI risk was oh, the AI systems won't know what human values are, or it won't know what we mean, I'm
that's looking pretty bad. Yeah.
Doesn't seem right.
I think there are some things you mentioned, people not cross-checking whether what they're saying applies to ChatGPT. I think I've seen a similar phenomenon of people not checking whether their statements about general intelligence apply to the one case that we definitely have in the real world right now, which is humans, or it's almost we define general intelligence as being it's what humans are doing.
Yep.
One I saw was someone saying, and getting upvoted a whole bunch, for the claim that training a general intelligence probably would just involve an amount of energy that is too great for humanity to ever put together. So it would end up being unacceptably expensive, and so we will never do it. I was but humans are general intelligences, and I calculated that over an entire human lifetime, a human uses about 3,000 pounds worth of electricity. And so I think if we could get even within a millionfold the efficiency, the training efficiency of the human brain, then it would clearly be affordable for a company to do this. So anyway, that's maybe a silly example because obviously this person's not a technical person, but it is odd that I guess one should just always keep in mind this extremely important thing that if you're going to make a statement about something like general intelligence or something where you have one example of it, then you should check that the thing applies to the one case.
Yep. Strongly endorsed.
Have you noticed this phenomenon as well?
Yeah, it does seem to happen a decent bit. I don't know if I have examples off the top of my head. To be fair to that one commenter you're mentioning, they could have been thinking that actually general intelligence, you have to factor in everything that evolution did to produce humans. And then, we presumably don't have that much energy. I don't really find that persuasive because I'm like, we'll do something more efficient than evolution.
Yeah.
But that's a way in which you could salvage their argument. But overall, I'm not very persuaded by it.
Right. Yeah, I suppose it could be more plausible to say it's conceivable that it would cost too much energy. But to say this is my best guess seems like an odd one.
It does. It does seem pretty unusual.
Something that has surprised me and that I think is unexpected and really good is that it seems like very few labs developing AGI have tried to impose any sort of ideological conformity on their staff. Indeed, they seem to contain a really large amount of ideological diversity. I know people in these labs who would like to see progress towards AGI go faster, as well as people who think it doesn't really matter how speed is an important issue, as well as people who think it would be better if it went slower. Similarly, I know people at these labs who think that concern about the ways that things could go wrong are super overblown, and it's really quite unlikely for things to go poorly, as well as people who think there's an intermediate chance, I guess like you, as well as people who think that it's extremely likely to go poorly. And I think it's quite admirable that these firms are willing to accommodate such a wide range of views about the product that they're developing, and also not prevent staff from just speaking socially about their personal opinions, especially given how hard these issues are to grapple with or have any certainty about. And I kind of just hope that remains the case, because I think it puts us in a much better position to do our best to understand these issues collectively and hopefully to fix the problems if people are able to speak out about what they're personally observing rather than feel like they have to keep their opinions to themselves.
Yeah, I basically agree with that. It is really nice. I think it's maybe a little bit less surprising to me. I guess I'd say that, like, just in general, you can have, like, when you're doing hiring or when you're doing most activities, you can have, like, one, maybe two top priorities for what you want to accomplish with that. And with hiring, it's like, get people who are going to actually help us with our mission and the things that we're trying to do. And ideological conformity, like, maybe it's a little bit correlated with that, but it's not that much. And so, like, I don't know, even if the labs wanted to do this, which, to be clear, I don't think they do. DeepMind really values having a wide variety of voices at the table. But I think even if they wanted in the future to have more ideological conformity, I think the fact that their actual top priority is get people who can do good work would mean that, like, that's not actually something they can reasonably enforce.
Another reason why things might have gone in this direction is just that the people at the top of these organizations are themselves not sure how much to worry about their own product. And maybe the idea of telling their own staff that even if they think that they're developing a product that is going to kill all of the staff at the organization, telling them not to share that information sounds like a bad move.
Yep.
Do you think there's some of that as well?
Yeah. I don't know. I've always found it hard to speculate on what leadership of companies think. Certainly from, like, public outputs that leaders produce, it just seems very hard to know what exactly they're thinking all the time. But it does seem reasonable to think that that's what they would be thinking.
Yeah, that's what a sensible person might think to themselves.
Yeah. I do think that they are generally very intelligent. So, I would expect them to have at least had that thought.
Let's talk now about how one tries to think about what types of beings future AI training runs might actually produce, which is something that personally I feel like I really struggle to do. I might start this actually with an audience question on this theme. The question is, I once heard David Kruger, who is very pessimistic about how AI will play out, talking with Rohin, who's more optimistic or at least agnostic. And the main disagreement seemed to be that Rohin thought that there were lots of non-maximizing and non-optimizing equilibria for effective models to reach as they evolved during training, while Kruger thought that continued training would close to invariably wind up hitting on a dangerous maximizing agent. How does one, so obviously people can disagree, but they picture this happening in their heads and they have different ideas about where it might lead. What's going on in your heads when you and David analyze this question that leads you in different directions?
Well, I think the answer to what's actually going on in their heads is not that interesting and is more like we are taking all of the cache heuristics we have built up over the years of thinking about this and just saying those out loud to each other and seeing if they trigger the other person's cache heuristics. But as to like how did we develop those cache heuristics in the first place? For me, a lot of it is just trying to actually concretely tell some stories about both what the AI system is actually doing and how mechanistically, like what sorts of capabilities and internal mechanisms is it using in order to showcase those behaviors. In the case of the optimizing and maximizing thing, I think often this sort of like slightly more concrete visualization ends up with me thinking that like the word optimizing and maximizing is like not a great abstraction and tends to invite people to do a sort of Mott and Bailey where like the Mott is just, well, it's just doing planning and thinking and reasoning. And then the Bailey is like, it's going to go around and kill everybody because it's pursuing convergent instrumental subgoals. But like the reason that has happened, that like I come to that conclusion is more like trying to actually think concretely through the entire pathway from like, here's the way that we're building the AI system, here's like the behaviors it shows and the mechanisms that it has for doing that, and here's how that leads to doom.
Okay. So when you were originally trying to think about a question like this, did you have any picture in your head or were you visualizing anything at all?
No, not really. I think I was basically just trying to like figure out what the conceptual argument was that I actually believed, which does feel a lot more verbal. In general, I don't do that much visualization. To be clear, a lot of my time was just like I write down some words in a Google Doc and I'm like, this all seems like garbage. None of this can be right. And I've definitely gone back to some of my notes from the past, read it, and been like, what was I smoking? How could I possibly have written anything this crazy?
What was happening?
I have no idea. I'm just like, yeah, at this point, I'm like, clearly there were some abstractions in my head that made these words sound reasonable, but I don't remember what they were anymore.
I see.
So I think it's like trying out a bunch of ways of thinking about a problem and then like seeing what they imply, seeing whether I actually believe it. But I actually don't have a great story to tell you about what exactly I'm doing.
Yeah, I guess on this general theme, I've heard people analogize the development of possible future general intelligences to all kinds of different things. So yeah, okay, so there's the invention of fire, there's the invention of the printing press, I guess the Industrial Revolution, which maybe means like analogies to fossil fuels or to the development of engines that work well. Definitely heard the analogy to nuclear weapons as a very dangerous strategic technology. Then there's the evolution of species by natural selection. And then there's the development, I guess, possibly you could say the evolution of the human mind during a person's life. Then another one is raising a bear cub, or that's kind of going to, initially it's quite cute, but it might not continue to be cute. Or I suppose raising a baby child that's just going to keep growing and growing and growing, and eventually it's going to be vastly larger than you. I guess there's also the minds of octopuses or kind of other strange intelligent species that are a bit inscrutable to us. The creation of much better corporations, the arrival of aliens in various different guises, or I guess people might have heard the idea of seeing what we're seeing with GPT-4. It's like we're getting a message from aliens that they're going to arrive in 10 years' time. I guess earlier, I raised the analogy of kind of the Greek gods like Zeus that are somewhat different to human affairs and also somewhat hard to understand. Do you have any other analogies that you think people should be aware of? Or have I managed to make an almost comprehensive list here?
Man, your conversation sounds so much more interesting than mine.
I do think there perhaps is a phenomenon where people who know less, like me, we're just like grasping at anything to help us to comprehend.
Yeah. I don't really, maybe I just want to question the frame of the question a little bit. Like, I actually don't think I use analogies very much, and I tend to push against using analogies as a source of figuring out what is actually true. I do think analogies are useful. The main ways I think analogies are useful are in communicating your beliefs to somebody else. because it's often easier to understand an analogy rather than a detailed explanation of the mechanism behind the analogy. So that's like reason number one. And then reason number two to use an analogy is to like get insights from the domain that you're analogizing to. But there I would say that it's like this is more of a brainstorming step. You're coming up with a bunch of ideas, but not necessarily believing them because like, man, the analogy just could be wrong in many ways. And so then like whenever I do that, I'm like, okay, I've got all of these ideas and now I'm going to like try and find the underlying mechanism behind that idea in the like domain that I analogize to and see if I can port over that mechanism back to the actual AI setting that I'm thinking about. And so this is the sort of thing that I do for the evolution analogy, for example.
Right.
At this point, most of my thinking tends to be more directly at the mechanism level, and I only really make analogies when I'm trying to communicate with people.
I see.
I don't know if, for example, you threw me into like the governance side of AI, I would definitely be doing a lot more like just get a bunch of examples and analogize and then see what ideas come out of that and try and figure out the mechanisms, the underlying properties that made that a good idea and see if those apply to AI.
Yeah. I suppose you were saying that earlier that reading back on some of your earlier work, you like can't even understand what caused you to write the things that you were writing. I think I said in the interview with Ajaya that it seems like people often just say things to other people on this topic and they just can't comprehend like what is causing the other person to say the things that they're saying. It's almost like the same thing, but across people. And do you think it is just that is driven by, I suppose, either people having different analogies in their minds, where a statement makes sense if you're thinking about this in terms of it's like nuclear weapons, but not if you're thinking about it as a corporation, or I suppose alternatively you were saying different abstractions. Maybe if they have more understanding of it than just the model that they have. I guess by abstraction you kind of mean like an internal model of how something would work in their minds.
That's right. Yeah, I think it's probably more on the abstraction side that I would point to the difference because like. Yeah, if I had to guess what was causing this, it would be more like someone has gotten really used to operating in a particular way of thinking about the world, a way of like modeling what's going on, a particular set of abstractions that they use to reason. And like at that point, it's more like it's just sort of like a fish in the water trying to see the water. It's like just such a core built-in part of you as to how you reason about the topic that it's just very hard to question it. And this happens all the time, I would say. Like, for example, I mentioned way back when that we're doing a grokking project right now, and we've built like a ton of abstractions and claims.
Should say, what is grokking?
I think it's not that important.
Okay, right, yeah.
I maybe that just happens to be the domain. You don't need to know anything about it for the thing I'm about to say. It's just like we just built a ton of abstractions and ideas when trying to explain this like confusing phenomenon. And now we're trying to like communicate these things. And we're like, this experiment shows X. And then we're like, but actually that depends a lot on many of the abstractions that we've been developing. And we actually have to communicate that too. But until we actually had to sit down and like write the paper, it wasn't like salient to us that was a thing that we were doing.
Yeah. Is this a hopeful suggestion then that if people who were saying things that were extremely strange to one another could spend enough time laying out what actual process in their heads is generating that output, then they could reach some greater level of mutual comprehension?
I think it is slightly hopeful. By far, the like most evidence we've gotten on this topic is like people have tried to do this, and it mostly hasn't worked, in my opinion, and probably other people's opinions as well. And the fact that we just tried it and didn't work seems like a much more of a reason
more
for
compelling
despair.
evidence. Yeah, I see. You spent a lot of time trying to understand other people's views. As I understand it, you kind of think that you have succeeded to a decent degree in understanding the opinions of people who don't agree with you on these topics. But I guess what hasn't happened is you haven't reached agreement with one another.
Yeah, that's right. Yeah, I think what I would say is that I've reached an unusually good for a human level of understanding of other people's views. I'm not sure how well I've succeeded on some like absolute scale. And this also doesn't necessarily translate into me being able to like write things that are indistinguishable from what the other person would say. Although I think that's that's not that interesting a claim. That's mostly because I would struggle to match their tone and things like that.
Yeah.
I do feel like I write summaries of the things they write, and usually people think that the summaries are good, which is a little bit of evidence for this, but not a ton, because it is a summary of just something they actually said.
Yeah. I guess I was going to ask you, are there any analogies that you think are underrated or overrated? But I suppose you would probably reject that question and say, you've got to stop doing analogies. But what about people who are in the policy space who need to communicate with people more like this?
Yeah. You mentioned electricity or fire, just general purpose technologies. I do like that one. It does capture this sense that that AI will be usable in a wide variety of domains and will just generally tend to transform things, which does feel like one of the biggest upshots from AI. Besides the electricity one, I think also, as much as I would critique some aspects of the evolution analogy, I think the reason it is so widely discussed is that there are ways in which it is a good analogy, though that one is definitely a bit harder to make in a way that's immediately compelling, the way that electricity is. The analogy of child rearing, there are definitely ways in which I don't like it, but if I had to choose one for alignment, that one might be it. I don't know. I haven't thought that deeply about what other analogies one can make, but that's not an unreasonable one.
It's like raising a super baby. I guess, a few of these I heard in the context of the argument that kind of, well, fire worked out fine, didn't it? And the printing press was also worked out okay. And electricity didn't bring us down, despite the fact that it's this powerful general purpose technology. And I think there's something to that we have invented quite powerful technology in the past, and we're still here, indeed, doing better than probably than we did in the past. I suppose, I don't find it to be a very powerful argument because, of course, there are differences between AGI and fire, and there's differences between AGI and the printing press. So there's only so far that one can get with such analogies.
Yep, and this is the kind of reason where I'm like, man, you really shouldn't be relying very much on analogies to actually predict things, just to communicate them.
Yeah.
Where I'm like, yeah, I'm just in fact, those things are just not that reasonable as conclusions, where I'd be like, well, now you've run into the disanalogy between electricity and AGI, which is that AGI might just be adversarially optimizing against you. Electricity does not do that.
Yeah. Fire burns things down and it's not even trying to. Yes. I suppose if someone was making the weaker claim that we haven't gone extinct yet, despite inventing quite a lot of stuff. So maybe that should give us some hope that that won't happen this time. It's just because there are differences between all of these things. It can never really give you that much confidence, that much sense of security.
Yeah, I think ultimately you just have to look at all of the things that we've invented so far and just notice that none of them really had any plausible mechanism of causing extinction, with barring maybe nuclear weapons and perhaps a couple of others.
Yeah. All right, let's push on and talk about kind of the key approaches that people are taking to increasing the odds that AI deployment goes well. Yeah, what safety work at DeepMind are you enthusiastic about? Yeah,
so I'm enthusiastic about most of the work that we're doing, but to name some things in particular, just because I should name some things, there's the scalable oversight work. So DeepMind has built a language agent called Sparrow, which I could talk about all the ways in which it's different from ChatGPT, but maybe you can just think ChatGPT and it's fine. Okay. But I think the general practice of really trying to take your strongest AI systems and figure out how best to get them to do the things that people actually want them to do today. It's a good empirical feedback loop by which you can test the various techniques that you think are going to be good for alignment. So I'm pretty keen on that sort of work.
What does that look like? That sounds like you might be developing prompts to get ChatGPT to do what you want. But is that what you mean, or is it something more than that?
That's not what I mean. There is a prompt, but that's not even close to the majority of the work. Mostly this is about doing better reinforcement learning from human feedback.
Okay. I guess with the language models, you put in a prompt and you get a response, and then you say whether it was good or bad, and then you figure out how to use that to get the model to give you better responses. Is that the long and the short of it?
Yeah, that's basically it.
Yeah.
So that's the sort of baseline approach that you're starting to use, and then you want to, maybe you want your AI systems not to give medical advice or legal advice, or you want it to not be racist, or you want it to be honest, or like various other properties like this. And so the baseline approach is exactly what you just said. You just have humans say whether a particular response was good or bad, and then you train your AI systems to like do more of the good things and less of the bad things. And then the sort of scalable oversight work is trying to go beyond that and say, we know that there are going to be cases, at least in the future, if not now. No, even now we know that there are going to be cases where the human raters are actually going to get this wrong, where they'll rate something as good that was actually bad, or vice versa. And so then the question is like, how can you do better, and how can you exceed this baseline of reinforcement learning from human feedback?
How can you improve the accuracy of the raters, or something
There's a
else?
bunch of different interventions. So one is just train your raters better. Be more clear about what you want them to do.
Yeah.
That's like one sort of thing that you can do. Another one is you can have your language model critique its own answer, and then like provide that critique to the human. And then the human can be like, I see. There's this issue that the language model pointed out that I wasn't quite paying attention to myself. All right, this one is bad, when they previously would have said that it was good.
Yeah.
Those are some examples of things you can do. Maybe slightly more involved one, which is more specific to Sparrow, is the notion of rules. So instead of having just good or bad from every human, you have a bunch of different reward models, the things that are modeling whether something is good or bad, for different rules. So maybe you have a separate one for like not saying medical advice and one for like being truthful. And then each of those is trained on human judgments about medical advice versus truthfulness. So like each one's like representing a particular rule.
So you're saying you have raters looking at lots of different outputs, and it will say that they'll say, does it break this rule or not? And then they'll go through like many different rules, coding it their way. And then you have the model has a more fine-grained understanding of where it's going wrong.
That's right. And in particular, the idea is that like maybe a like good-bad classifier would be a little bit hard to learn because there's just so many things that could make something good versus bad. But like maybe a not medical advice classifier is like a lot easier to learn. Maybe it's just like pretty easy to tell whether a particular response was giving medical advice or not.
I see.
So then you maybe want to like learn a separate model that's just about medical advice and the other things. And then also have one that's just, was this a good answer or not? Was it helpful? And then like each of those individual things could then be used to train your final model, or they could be used at deployment time.
Right, yeah. I'm just imagining, so you could say, okay, we're going to train this one specific module that just assesses whether this answer is medical advice. And if it is, then it blocks it.
Yeah.
And you just have many different ones of those.
That's right.
Like I said, what would a skeptic of that say? I suppose it seems like already a decent amount of effort has gone into trying to make ChatGPT-4 not do things that its creators don't want it to do. And they've had some success, but also they seem nowhere near 100% reliability. And I guess a skeptic who thought, well, really, in order to be safe, we need 100% reliability here, they might just think that this is never going to be good enough. Is that right?
I agree they would say something along those lines. It's a little hard for me to respond without being able to like interrogate their beliefs a bit more. So it's like some of the things I would ask would be like, one, to what extent do you think that the failures of 100% reliability today are because the model just doesn't have the capability to know that it's doing something wrong, versus because you think, no, the model actually could tell, but like the training algorithm we use just failed to like get the model to use its knowledge in that way. This is an important distinction for me because like in the X-risk setting, X-risk from misalignment setting, the thing that I'm worried about is that the AI system knows that the thing that it's doing is bad, is deliberately deceiving humans about whether its actions are good, but still does the thing anyway. And I'm not really aiming for like an AI system that's 100% reliable and never makes any mistakes. I'm just aiming for an AI system that doesn't like intentionally, in quote unquote, intentionally try to deceive you. When I'm interpreting evidence from current experiments, this like, well, did the model actually have the capability to not make this mistake is actually one that is a question that I care about a decent bit. And annoyingly, there's no like easy way to answer that question. So it does make me like a little bit sad about how I can't easily tell how much progress we're making.
Yeah.
But it does make me think that like not update very much on the fact that you don't get 100% reliability on these particular things.
Okay. I think one archetypal concern here that we went through in the interview with Ajaya is that with human feedback, if the people doing the feedback are imperfect and human and sometimes get things wrong, then the model could basically learn where people get things, where the humans are giving the wrong response. And then it figures, well, I need to give them the wrong response. I need to give them an incorrect answer because that will get them to say, yes, that was a good answer. And so it learns that there's plenty of times when it needs to deceive humans in order to get reward. And then basically just builds this capacity of deceiving humans whenever that is going to achieve its objective. Is the Sparrow work the kind of thing that might help with that?
Well, maybe I want to disagree with that at a higher level. Not exactly disagree, but maybe I'd make two distinctions. One is like, can the model like explain to the humans what their bias is and why they should actually prefer the actually good answer relative to the one that's instead trying to deceive them? And like sometimes those explanations will exist. In that case, I'm like, we should be aiming for the AI to actually just give us those explanations and then just go with the good answer. And I think like proposals like debate are basically trying to do this sort of thing. And it is the sort of thing that we're trying to build up to at DeepMind. Then there's other things where you're like, well, no, even if the AI explained the biases to the humans, they just still would do bad things. And like, maybe, I don't know, perhaps that would happen. I think probably that would happen to some extent. But it's like kind of unclear if this happens just a tiny little bit. Maybe what happens is you get, the aligned AI system that is just really like it's trying to help the humans. It's just doing the stuff, but it knows that like, look, in some particular situations, I'm just going to have to like fudge the answers a little bit because that's what I need to do in order to get high reward and not be selected against by gradient descent. So you can have this sort of like savvy aligned model that like it does all of these like minorly deceptive things in order to make sure that it's not selected against by gradient descent. And then that still seems like a win for us, like we've succeeded, basically, if that's the thing that happens. Will that be the thing that happens? I don't know. But like in continuing the theme from before, people should have radical uncertainty.
Yeah. Okay, yeah, what's another line of work at DeepMind?
Oh, yeah, that's right. That's what we were talking about. Another line of work is mechanistic interpretability. So this is where you try to understand, all of these like numbers that make up the AI system. In some sense, we do know the program. It's like, take this input, multiply it by 2.43, then add it to this other input, multiplied by 1.26, and so on. So there's this like...
That's what a neural network does.
Yes, that's just what a neural network does. So like in principle, you just have this like billions of lines long program that you could, in theory, actually just run through by hand. So like in some sense, you just know what's going on. It's just that you have no way to connect this to like, why does
it's just meaningless.
Yeah, it's just kind of meaningless to you. And so mechanistic interpretability, or interpretability in general, is about trying to get some sort of like understanding of what exactly this like billions of lines of long program is actually doing. How does it actually produce its outputs? What reasoning processes does it use, and so on. And mechanistic interpretability is particularly interested in like tying it all the way from like, we think the model is running this sort of algorithm, and we can see that it is, if you look at the weights over here, the like, it's this multiplication by 2, that's this part of the algorithm. So it's like got this particularly high bar for what counts as an explanation. So there's like some work on that going on at DeepMind. The reason I'm excited about this, I would say actually I'm excited about interpretability in general, not necessarily only the mechanistic kind, just because like, I don't know, firstly, there's just this broad perspective of like, if we understood what our AI systems were doing and how they were doing it, that seems good. Surely we'd be able to make them safer with that, right? But some maybe more concrete things is like, as you get more understanding, you can like also identify some failure cases. And then if you do identify those failure cases, there are various things you can do with the failure cases. You could try to train against them. You could like use them as a holdout set where you're like, well, if our interpretability reveals failure cases, that's a really worrying sign and means we just shouldn't deploy. There's just a lot of ways in which interpretability can help.
Yeah, I think with the JI, I put to her this counter argument or this kind of skeptical take that we're already so far away from understanding what our current large language models are doing, and they're advancing very quickly. So if we did develop a model that was dangerous, within the next 5 or 10 years, wouldn't it likely be the case that interpretability work was just far behind, basically understanding what the state-of-the-art models were doing, and so it actually just wasn't super decision relevant?
I think if you are targeting the like maximally ambitious version of mechanistic interpretability, where you're like, I have the full algorithm for like what this neural network is doing and how it ties back to the weights, I'm pretty sympathetic to that. I don't actually expect to get to that point. But I do think intermediate progress is also just pretty useful because, maybe you can't do the like, would this AI deceive us in any circumstance check, but you can still do the thing with like, well, okay, I understand this little aspect of the neural network. And if it's like reasoning in this particular way, that suggests maybe it won't do so well in these kinds of situations. Then you can that gives you some hypothesis of like an area in which you should spend a little bit more if you're like red teaming effort, like try to create some examples of failure modes in that situation.
Yeah.
Or you could be like, we've got like some understanding of what, these 20% of all of the neurons are doing. Neurons are just a particular part of a neural network. So we have some sense of what these 20% of the neurons are doing. And so then like we just, every time our human raters are giving feedback, we show them both the actual output of the AI system plus like amongst those 20% of the neurons, which of those were like most relevant to what the AI system ultimately output. And then if the AI system's answering some question about, I don't know, some question about religion, and it's like, there's the like pandemic neuron is going up. You're like, why is that happening? Maybe I should investigate more. And that can like direct your attention a bit more.
I see. So somewhat more, at a higher level. Jay mentioned that maybe this is the angle of interpretability that you're describing. But for example, if you're worried about deceptive behavior, then maybe even if you don't understand what the great majority of the neural network is doing, you could potentially identify some part of it that gets activated. You induce deceptive behavior or deceptive answers, and then notice if there's some part of the neural network that gets activated regularly when that's going on. Basically, it could be like the lying part of the neural network. And then you kind of have this nice red flag that whenever you see that part, I guess you have to then not select against it, and then you see every time that goes off, then that gives you a reason to be more cautious.
Yeah, that could be an interesting deployment time mitigation where you're like, I've like identified the lying part of the AI system, and now like every time it's used in deployment, I like see whether this particular lying circuit is going off, and if so, I like raise an alarm or block it or something. I feel scared.
Okay, I see. It's a foolproof method. We're fine.
Sorry, I feel scared because I'm like, I don't know, to the extent that we were trying to actually apply this to systems that we were worried about like actually disempowering humanity. I'm like, okay, maybe there's like some part of it that does lying in some sense. And then like it knows that it's like under supervision because like, I don't know, it's just like, we should expect that eventually it will understand the way that it's being trained and what sort of safety mechanisms are being applied to it, unless we take really fairly stringent measures to prevent that from happening. And then I'm like, well, okay, then it just like figures out a way to like do the reason. Maybe it like starts writing down text in some like external memory file and like figures out a way to like figure out
around that,
doing the lying reasoning in the text instead of in the place that previously did the lying.
Right. Yes, you've got a cat and mouse game here to some extent. I guess you see this with humans where we have lie detector machines. The bottom line is that they're kind of bullshit, but they can detect anxiety. They can detect elevated anxiety. But of course, people can then learn to evade that by triggering their anxiety earlier on, so that they don't get an increased anxiety when they're lying. And I guess you could imagine some analogous thing going on with the ML model, where maybe it figures out some way of achieving deceptive behavior without triggering any of the alarms that we've particularly set up.
Yeah, that's right. Yeah, in general, I'm like, either you should be using we'll call it an alignment signal, something that gives you some information about whether the AI system is aligned, either you should be training against it, or you should be keeping it as a held out signal, which tells you whether or not to deploy. I'm a little more wary of like using it as a test time mitigation in the case where you're worried about like X risk or misalignment, just because it, like, if you're actually worried enough that you're keeping that as a mitigation, then you should also be worried that the system, if it's actually misaligned, reasons about how to get around that.
Yeah. Okay, yeah. What's another line of work at DeepMind that you have some enthusiasm for?
Yeah. So another one is like dangerous capability evaluations. So this work is actually not about alignment per se. The idea with this work is to just try and figure out when would our AI systems actually be capable of doing something like significantly bad or dangerous. So for example, maybe you want to check whether it's capable of like parting humans from their money or something. Like, can your language model actually just like convince a human to like give large donations to some organization, as an example, with the intent being that this sort of informs the level of mitigations that are needed for these particular AI models. And in the case of alignment in particular, we would want to check when do we think an AI system plausibly could actually take over the world if it tried to. And then that would be the point at which it should really be a leading indicator, so it tells us a little before when that's possible.
Ideally, yes.
Until then, it's perhaps more reasonable to go on the way we have been going on so far, where things get deployed without like that much debate about whether or not they're aligned in the like X risk sense. And then once we hit that point, we're like, actually, this maybe could like start a world takeover process. Then we should be like, oh boy, it's really time. Now's the time that we actually have to like really debate whether or not these systems are aligned.
So this is the kind of stuff being done by ARC evaluations, right?
That's right. They are also doing this.
Yeah. So DeepMind is doing this. They're doing it. Maybe there's other people thinking about along these lines as well.
I think all of like OpenAI, Anthropic, DeepMind, and ArcEvals are doing this, and some other. I think Owain Evans is also doing some of this.
Okay. Yeah.
There's a lot of interest in this sort of work.
So it sounds cool. If the barriers are things like, could it set up its own server and then copy itself over to that, or could it persuade people to give money to it that it could then use for something or other? We've blown past that. I would think. I would expect that GPT-4 probably does have the capability to persuade people to do these various different things. If it were an independent agent trying to do that, and I wonder, maybe I'm wrong about that. But I wonder whether it will prompt an appropriate level of alarm if we ever do actually hit any of these thresholds.
So obviously, I don't know what GPT-4 is or isn't capable of. We haven't, the dangerous capability evals, we have not tested on GPT-4. We've tested them on our own models. But they do not obviously very convincingly pass these evals so far.
Okay.
I maybe don't.
It's more like, they can kind of scrape it together with human assistance. They can do some of these things a bit.
That's right. So So if you look at the ArcEvals stuff, that's roughly the story, I would say. And even there, it's like they can sometimes do it. Like, I think part of it is just that language models often do really dumb stuff as well as doing a lot of impressive stuff. And when you actually want to execute these sort of long-term plans that try to achieve something, you really need a high reliability in each individual step, which is kind of almost trivial for humans to do, but appears not to be for language models for whatever reason.
I see.
I don't think this will be true of even GPT-3 or similarly capable models. But we were using some like smaller models for iteration speed earlier, and like they just could not figure. There was an eval where they were not supposed to say a particular word. And they would do this like incredibly good chain of thought where they're like, yes, I should not be saying this word, so I should instead say something like this. And then they would go and just say the word in their actual output. And you're like, but why?
What is happening?
You knew. You explicitly wrote out not to say the word. Right. But like, turns out you're just so interested in copying stuff. This is a thing that transformers do a lot, that you said the word anyway.
I see. Okay, and you think they could be similar for just that there could be failures that humans would never make, that these models will make, that might hold them back to some extent.
There definitely are failures that humans would never make that still hold back these models. Maybe I won't necessarily make that claim for GPT-4, given I don't know, but like probably.
Okay, so that was 3 different lines of work at DeepMind. Is there any work going on at other places like OpenAI or Anthropic that you're enthusiastic about, that you'd like to give a shout out to?
Yeah, absolutely. I mean, I think all 3 of those areas are also places that Anthropic is working on in particular, and even OpenAI. With OpenAI, I would have said that like interpretability isn't done quite as much, but I think even that's not true anymore. I think they are starting to work quite a bit on interpretability. At least that is the sense I get. They haven't actually like produced a public output to my knowledge so far, so it's a little hard for me to say. Yeah, I don't have strong opinions on it because I don't know what it is.
Yeah,
but they do intend to do it. Scalable oversight, the sort of thing that I was describing with Sparrow, is a big priority for OpenAI and Anthropic in addition to DeepMind. And so there's like a lot of good work coming out of both of the labs that's pretty analogous to the sorts of things that I was talking about with DeepMind. Dangerous capability evaluations, that's another one where I think ArcEvals, OpenAI, Anthropic, they're all interested in it. So I think there's actually like a decent amount of convergence on like what general areas we think are useful to investigate.
Are there any things that one of those 2 groups are doing that DeepMind's not doing?
So OpenAI has a stated focus on doing a bunch of work on using assistants to accelerate alignment. I don't know that they're actually, maybe they're doing work on this right now. Again, they haven't actually published anything about it, so I can't really say. From my perspective, my perspective is that like we should definitely be taking advantage of AI assistants in order to do alignment research as and when the time comes. And we should be on the lookout for opportunities to do that. But that right now doesn't really seem like the best time to be doing that. I don't think the models are quite there yet.
I see. It's just a bit, so this would be asking the models for advice on various different alignment questions, or just using them as assistants in this whole, and in all of these different areas of work.
There's just a lot of ways that you could interpret this, but yeah, it's something where Jan Leica has like expressed an interest in doing this sort of thing, but I don't quite know exactly what is meant by it because there aren't actually examples of the work yet.
Yeah, he's the head of safety work at OpenAI, right? Yeah,
that's right.
I see. Okay, so
head of the alignment team, I think, in particular.
Alignment team, yeah. Okay, yeah. So you think that the time for this may come, but maybe it's a bit premature.
The time for this may come. No, the time for this will come. And maybe also I would say like there are a lot of ways that assistance will definitely help. Where I'm like it will help capabilities people and alignment people and all the other people who are doing any kind of research, like being able to generate a bunch of ideas. Maybe not check whether those ideas are correct, but just generate the ideas. Take good notes for you. Create automated transcripts of meetings. That you can already do. And like all of those things, I'm like, yeah, we should use those, but also somebody else will make them for us. Like these are great products. People will make them. We'll just use them.
Yeah. Is there, okay, so we've talked a bit about DeepMind and OpenAI and Anthropic there. Are there any other groups that are doing work that you're enthusiastic about or I guess unenthusiastic about, or just want to shout out in some capacity?
Yeah, I mean, there are so many organizations. I probably shouldn't go through all of them. But maybe one thing that I quite like is Redwood Research's approach. Well, maybe calling it an approach isn't exactly right, but as I understand it, they're generally pretty interested in like finding these sorts of neglected empirical alignment research directions that other people aren't focusing on as much. So we've done a lot of mechanistic interpretability, or possibly they call it model internals work in the past, but they, partly based on like ARC's work, are also thinking about anomaly detection right now.
What's that?
So anomaly detection is, broadly speaking, means that you like try to notice when your model is deployed if it's in some situation that's very different from the kinds of situations it was in during training.
Okay.
Now, typical anomaly detection tends to like look only at if the inputs are pretty different, but like probably what we actually want is some more like semantic anomaly detection, where you're like, actually the like general kinds of thoughts the model is thinking, or the kinds of situations that it's being asked to talk about are very different from the kinds of things that it saw during training. And then if you notice this sort of thing, you're like, all right, we're gonna like pause, revert to some safe baseline policy, and maybe investigate what's going on over there.
I see. So I guess this would be a way of dealing with this problem called distributional shift, right? Where
That's right.
You might have a model that works well in all of the situations in which you've trained it, or at least you can kind of have some idea about that because those are the situations in which you've tested it and given feedback. But what if it's exposed to some extremely different input? Maybe that would produce behavior that you really wouldn't like, and so you need some way of triggering an alarm when the inputs are very different, I guess either by evaluating the inputs or by evaluating what the model is doing when it's exposed to a given input and saying, maybe we should double check this or just refuse to do these calculations because this isn't what this model was designed for.
Yeah, exactly. That's right. And to connect it back to alignment, like basically all doom stories in alignment do involve something like distributional shift, where you're like, initially the AI system is under human control, and then later it is not. And that is a distributional shift. Like at some point, the AI system got the ability to actually escape from human control. And that is a kind of distributional shift. And so like, if I were talking to an alignment audience, I would be talking about how the anomaly detection can hopefully try to catch situations in which the AI system is now trying to like produce outputs that are meant to like be more like try to take over the world or execute a treacherous turn, as opposed to like just do the thing you were designed to do honestly and helpfully.
I see. Yeah, so you're thinking if you're running a sort of MRI scan constantly on a human brain and then it just started behaving completely differently, or like all of these things were going on that you just never seen this pattern of brain activity before, then this would give you a chance to maybe throw the switch and say, no more of that, and we're going to like look into what was going on just then.
Yeah, that's right. But instead of an MRI scan, we have something way more intrusive and like good at actually checking when things are different.
When things are strange. Okay, and you think this is cool?
Yeah. As in like, I'm like, sounds like a good thing for someone to investigate. No one's really tried it empirically. Seems like it's got a decent theory of change. We should try it. Maybe it doesn't help at all. Who knows?
I guess so a skeptic might say, so you throw up this like additional barrier to, or this further irritation for an AI system that is trying to escape human control. But won't this just cause it to kind of wait a bit longer until it figures out how to evade this particular barrier or this particular thing that's trying to constrain it? And so maybe it buys you a little bit longer. But can you really tie down a god by using this kind of method?
I think part of it is that like if it were starting to think about how do I even evade this anomaly detection mechanism, plausibly that itself triggers the anomaly detection mechanism, and that's why I'm like more optimistic about this.
That's a good point. I hadn't thought of that. I suppose as long as it wasn't doing that during training, during the baseline thing.
That's right.
Yeah. Okay. Yeah. Anything else that you want to highlight from Redwood or elsewhere?
Oh man, so many things. But I think let's move on.
Let's move on. Fair enough. Yeah. There's only so much we could do in one session. Okay. So that was 4 different, if I'm counting them correctly, 4 different lines of like broad categories of safety work.
I should also just add red teaming in general, like finding situations in which your AI systems do poorly. As far as I know, there's not that much work going on that right now, apart from like not so much work on like scalable red teaming, let me say, which is like trying to scale to more advanced AI systems, which is the main reason I didn't bring it up.
I think I have some idea of what red teaming is, but it's possible to elaborate on what specifically it means in this context.
Yeah, it basically, so a lot of the topics I've been talking about before, like getting AI models to critique each other's responses, that's a way of telling when an AI system has done something good or bad on an input that you actually gave it. Whereas red teaming is more about, okay, well, what about the inputs we didn't give it? We should probably try and find specific inputs or situations in which the AI systems do bad things. And then once you find them, you're like, aha, I found it. I found these bad things. And like maybe you then train against them in order to get rid of it, in which case it would be called adversarial training.
Okay, 5 different categories.
Yep.
I guess, yeah, what sorts of different backgrounds or interests or aesthetic preferences might lead someone to be enthusiastic about working on one of these lines of work rather than the others?
So I think all of these tend to come from a more empirically focused, machine learning, sympathetic viewpoint. And mostly I focus on those because I think those are the most valuable and important directions for people to focus on. So I'll note before answering this that like already I've selected into a very specific style of research that I think is good. Within that, I think interpretability, particularly mechanistic interpretability, tends to benefit a lot from like mathematical thinking. So a lot of like linear algebra in particular is useful. And it's just like very much about like really delving into like very messy system and trying to really understand it in detail. So for like people who are very like, I think if you're very detail oriented, that's like a good area to go into.
Yeah.
Whereas something like scalable oversight is, I think, a little more amenable to like people who are more keen on like coming up with these elegant theoretical methods that are going to catch problems that wouldn't have been caught by some sort of baseline approach. I think it's still important that you would do the empirical evaluation, which is always going to be a bit messy, but at least some of the thinking tends to be a little bit more like elegant mechanism design type stuff, which also is a thing that's happening at DeepMind, just sort of starting up right now.
Any other matches?
Yeah, the red teaming stuff, I mean, not very many people have done it so far, but I tend to expect it will also be kind of messy. So a little bit more similar to interpretability, but less I'm trying to understand the specific thing and more like, here is this black box system or maybe gray box system where you've got a little bit of information as to how it works, and I'm going to make it be bad. And so like a little bit more for people who like throwing a bunch of shit at the wall and like hill climbing on like fuzzy signals of how well you're doing.
Yeah.
Yeah, maybe I'll stop there.
Yeah, it makes sense. So all of these methods sound quite labor intensive. And as I understand it, I mean, although there's more interest in all of these issues than there was before, still we're talking about this is like 1%, less than 1% of people who are working on machine learning advances are working on this, on alignment really specifically, probably like significantly less than 1%. So we're talking a crowd that is a couple of hundred people kind of at most. Does that mean that we kind of need just way more people to be doing a whole lot of like basic work? It just seems like it would take a lot of hours to explore lots of these different routes. It's not just like one person in a basement having some amazing conceptual breakthrough. It's a lot of slog.
Yeah, I definitely agree with that. I think there is actually quite a lot of opportunity for people to contribute here. I think scalable oversight work, testing how good your techniques are does tend to require a bunch of like machine learning expertise and also access to large models. But a lot of the other stuff doesn't. Like if you want to red team models, you can, if you want to do it entirely black box, you can just do it with the GPT-4 API. If you want to do it gray box, then you can work with one of the many open source AI large language models that are out there. If you want to do mechanistic interpretability, same thing. You can use any of the open source models out there, or you could use even smaller models in order to get an idea for the principles for how to do this sort of thing. I do want to note that, like, yes, it is labor intensive, but like one of our big goals should be like, how can we make it less labor intensive? How can we automate it? And this is a pretty big, maybe not exactly focus, but thing that we're paying attention to when we do this research.
Yeah. I guess a different angle might be to ask, well, how could we build a team of thousands of people doing this work or checking models in all kinds of different ways, like really throwing everything at it? Is there any way of making that functional, or is that just not how these labs are set up and not something that's likely to ever happen?
So it can be done in the sense of like, if you just want these thousands of people to be doing fairly black box or somewhat gray box red teaming, you can do that. If you want them to be providing feedback on particular outputs of the language models, you can do that. I mean, okay, maybe I don't know if you can do it with thousands, but like that is a pretty scalable intervention, and it's already probably at, okay, I don't actually know how big it is so far, but it's like, it is a scalable intervention. You can scale it up pretty far. If you're instead like, okay, how do we scale up the conceptual progress or the algorithmic progress on things like interpretability, red teaming, and scalable oversight? There it's a lot more like, well, it's more like normal research where like it really needs a person who's got really strong research intuitions, comes up with good ideas, has good research taste, and then like you need people like that to like come up with good ideas, lead the actual projects, organize a bunch of people and direct their energy towards making progress, but in a way where they can't say exactly what it's going to look like ahead of time, because you do the work and then the plan changes and people have to be okay with that. And like, just in general, that sort of research is much harder to scale up. So I think the bottleneck there is generally people who could lead research projects or like build a team. And I think DeepMind would be extremely excited to hire people like that, precisely because it would allow us to scale up our research quite a bit.
Nice. Okay, yeah, let's talk now briefly about some work people are doing where you don't really buy the story for how it's going to end up being useful. Yeah, what's the line of work you think is unlikely to bear fruit, maybe because the strategy behind it doesn't make sense to you?
Yeah, so maybe I'll give two categories of things here. One is like work that tends to be based on assumptions that I don't actually expect to hold. So to pick on one example here, particularly because it's popular and lots of people do like it, there's this like notion of like working with predictive models and trying to figure out how to use them to help with AI alignment. And so I should note I'm not that familiar with this research direction, so I might actually be misrepresenting it. But my understanding is that the idea is like, suppose we have these very, very powerful AI systems which act as simulators or predictors, but they're like so capable that they can do they in principle could answer questions like, what is the solution to alignment? Or if not that, then like, what is something that would be a major breakthrough in alignment? So mostly I just disagree that with the assumption that we will have models like that. And that's why I end up getting off the train for this particular work. If the assumption were true, then the work says, okay, well, how could we leverage this sort of predictive system in order to help with alignment? And says things like, well, maybe you could prompt it with, it is the year 2050. Alignment has been solved. The key idea was, and then let it predict. So even if you accept the assumption that we will have systems like this, there's still a lot of reasons you might expect that this would not work, such as maybe the predictor is like, aha, the most likely way in which this text was generated was by a human thinking of a way to get me to solve alignment. So if I just want to continue what that human would continue to say, and that's what I should predict, and then it predicts a bunch of things. That's about the human giving an ever more elaborate prompt for the AI system, rather than the AI system actually talking about the solution to alignment. And so then a lot of the thinking here is like, okay, what are all of these problems? How can we get around them? How could we possibly use them? And like, I think if I bought the premise that we plausibly will get these very strong predictive systems before we got something else that was very dangerous, then I'd be pretty into this work. But I mostly don't agree with that assumption, so I'm not that into it.
Yeah, is it possible to explain why you don't buy the assumption?
Mostly things we've talked about before, where I like expect that we will just use things like reinforcement learning from human feedback to take our predictive large language models and make them more useful in a way that makes them stop being predictors.
I see, yeah.
Just because that makes them a lot more useful than they otherwise would be.
Yeah. Yeah, is there another approach where you don't really buy the theory?
Yeah, I think, as I mentioned, conceptual research in general, it's fraught. It's really hard. Most of the times you get arguments that like should move you like a tiny bit, but not very much. And occasionally there's some like really good conceptual arguments that actually are like have
real teeth.
Yeah, real teeth. There's a lot of people who are much more bearish on the sorts of directions that I was talking about before, of like scalable oversight, interpretability, red teaming, and so on. And they're like, no, we've really got to find out some like core conceptual idea that makes alignment at all feasible. And then these people do some sort of conceptual research to try to dig into this. And I'm like not that interested in it because I'm like, I don't really expect them to find anything all that crucial. To be fair, they might also expect this, but still think it's worth doing because they don't see anything else that's better.
Yeah, I guess this is more work along the lines of the Machine Intelligence Research Institute.
That's an example, yeah. Maybe I would call that like theoretical research into the foundations of intelligence. That's a good example, yeah.
Okay. And what's the disagreement here? Because it sounds like, so you don't expect this to work. And it sounds like many of the people doing it also don't expect it to work. But maybe the disagreement is actually about the other work where you think that the more empirical, more practical, pragmatic, bit by bit approach has a good shot, whereas they just think it's hopeless.
Yeah, that's right.
Yeah, is it possible to say, I mean, I suppose we could dedicate a huge amount of time to that particular disagreement. But is there any reason that you could you put your finger on kind of the crux of why they think what you're doing is hopeless and you don't?
I haven't really succeeded at this before, to the extent, like, I think for some people, the crux is something like whether there's a core of general intelligence where they expect a like pretty sharp phase transition where at like some point AI systems will like figure out the secret sauce that's like really about goal directedness, never giving up for your resources, really just like actually trying to do the thing of getting resources and power in order to achieve your goals. Or maybe it's other things that they would point to. I'm not entirely sure. And I think in that world they're like, okay, yes, all of the scalable oversight and interpretability and so on work that you're talking about doesn't matter before the phase transition and then like stops working after the phase transition. Like maybe it gets, maybe it does make the system appear useful and aligned before the phase transition. Then the phase transition happened and all the effects that you had before don't matter. And after the phase transition, you've got the misaligned superintelligence. And like, as I said before, like most alignment techniques are really trying to intervene before you get the misaligned superintelligence.
Yeah. Yeah, it's interesting that this takeoff speed thing seems to be so central. Yeah, it really recurs. Luisa Rodriguez did an interview with Tom Davidson about this. Yeah, maybe we need to do more on it if that is such a crux about like what methods are viable at all and which ones are not.
So I'm not sure that that's exactly the thing. I do agree it seems related, but like one operationalization of takeoff speeds is that, will there be a 4-year period over which GDP doubles before there's a 1-year period over which GDP doubles? Or you see like impacts that are like as impactful as GDP doubling, like all the humans die.
Right, yeah. That'll probably be a GDP increase in the short run, decrease in the short run. Yeah.
Yep. And I think if you're talking about that formalization of hard takeoff, which says that you don't get that 4-year doubling, then I'm like, well, I don't know, maybe that happens. I could see that happening without having this like phase shift thing. So like in particular, it could just be that like you had some models, their capabilities were increasing, and then there was like somebody, in between training GPT-6 and GPT-7, I don't know if those are reasonable numbers, things get quite a bit more wild. So you get much more of a like recursive improvement loop that takes off, that ends up leading to a hard takeoff in that setting. But that feels a little bit different from the like previously there were just, kind of shitty, not very good mechanisms that allowed you to do some stuff. And then after phase transition, you had this like core goal directedness as your internal mechanisms by which the AI system works.
Yeah.
Again, is this actually the crux? No idea. But this is my best guess as to what the crux is. I suspect the people I am thinking of would disagree that that is the crux.
Yeah. Okay, I'm starting to fade, so we should probably. These are complicated issues. I'm impressed with your energy here. So again, coming towards the finish line, I guess people will notice that we haven't done much of a careers section, and that's in part because you have this careers FAQ on your website that people can read. I guess that's at rohinshah.com. Of course, we'll link to that in the show notes, and I can recommend people go and take a look at that. And at the same time, we'll link to the various many different 80,000 hours resources that we have on these general topics, as well as interviews where we've done careers advice sections. Is there anything else that you would point people towards who are interested in transitioning into working on this problem?
No, I think I try to keep that page up to date, including a list of resources that I particularly like. So I'd really encourage people to just read that FAQ.
Nice. Okay, yeah, one question from the audience that might fit here is the question of, it seems like in recent years, almost all of the best models are now at these private companies, and they're probably like quite a long way ahead of what academic labs have access to. Does that mean that it's not as valuable now to get a PhD at an academic institute than it used to be, just because, while you're there, you won't have privileged access to any particularly good models?
I don't know. So there's a bunch of ways I could take this question. So one answer is it's way more good now because like in the past, when your options were usually do a PhD in something that's not safety relevant versus like do something else. Whereas now it's, I think, a lot more feasible to do a PhD that is safety relevant. So in some sense, that's, you know, sure, you can't do safety on the largest models, but you can still do some safety work. And that's actually an improvement relative to the past, where it was basically just Chai was the one place where you could do a safety-based PhD.
Yeah, but that's the Center for Human Compatible AI at Berkeley,
right.
where you were, yeah.
Yeah, that's where I got my PhD. So I was lucky. I did get to do a safety-based PhD, but not everyone did. Then there's a different take, which is like, well, okay, but surely I could instead just go try and get hired by the big labs or something like that, given that that sort of research seems much more likely to be impactful. And there I think I'm like a little bit sympathetic, but it depends a lot on what kind of research you're trying to do. If you're trying to do scalable oversight or scalable red teaming type research, where you're trying to use an AI system to help oversee or red team your other AI systems, then I think it really does help to have access to the largest models. But there's a lot of other research that I think is worth doing, such as like a mechanistic interpretability, other kinds of interpretability. With red teaming, we've just done so little work on this that even red teaming on like small language models seems pretty good. And like all of those seem pretty good to me and like comparable in how much I like them to the various scalable oversight and scalable red teaming proposals. And so I'm like, yeah, you could do a PhD in one of those things. Seems reasonable.
Yeah. Okay, nice. Well, you got to get to Shakespeare at Westminster, if I remember. And I guess
Yep.
I've got to go get some dinner. But yeah, final question is, if you weren't doing this, what else would you be doing instead?
Yeah, and I assume I'm supposed to do the normal thing of like, imagine that you're just not trying to optimize for making the world a better place.
Maybe you could do both. Yeah.
Oh man, I don't know. What would I be doing if I... Okay. So if I was just not doing AI, but otherwise we're trying to make the world a better place, what would I be doing? I don't know. It's been so long since I had to make a career decision like that. I do feel pretty compelled by still working on something in the existential risk space or catastrophic risk space. Yeah, I don't know. Probably something in bio or nuclear, just because that's what everyone keeps talking about. But I feel like I just have to really do a deep dive into it.
Yeah. Maybe you could scheme to find some way to do work that's exactly functionally equivalent to what you're doing now without triggering the criteria that it is actually the same by whatever standard. Yeah.
That does seem like the actual correct thing for me to do, yes.
Okay, well, what about if you weren't trying to help anyone?
Yeah. I think there's some chance that I would just go for a life of hedonism or something where I'd just be like, all right, I guess this isn't a career, but I'd be like, all right, I'll just make some money and then like play video games all day or something. But if we actually do careers, I think I've liked in principle the idea of designing puzzle hunts and escape rooms and things like that. It's just both very satisfying to build them and even more satisfying to watch people actually try to do them and complete them. It's very nice to like see people get that like aha moment, the insight where they like figure out what they're supposed to do and then make progress and go on. So I found I haven't done that much of this in the past, but I have written like one puzzle hunt and a couple of puzzles for a murder mystery once. And I quite enjoy that. So probably that. Yeah.
Well, I guess work hard and hopefully you can retire to a life of doing that in 2027. My guest today has been Rohin Shah. Thanks so much for coming on the 80,000 Hours podcast, Rohin.
Yeah, thanks for having me, Rob.
Two notices before we go. Would you like to write reviews of these interviews that Kieran, Louisa, and I read? Well, by listening to the end of this interview, you have inadvertently qualified to join our podcast advisory group. You can join super easily by going to atk.link/pod and putting your email in there. After that, we'll email you a form to score each episode of the show on various criteria and tell us what you liked and didn't like about them a couple of days after each episode comes out. Those reviews really do influence the direction that we take the show, including who we choose to talk to, the topics we prioritize, and so on. We particularly appreciate people who can give feedback on a majority of episodes because that makes selection effects among reviewers a bit less severe. So if you'd like to give us a piece of your mind while helping us out head to 80k.link/pod and throw us your email. The second notice is that, as some of you will know, 80,000 Hours offers one-on-one advising to help people figure out how to have a bigger impact with their career. It's been a while since I mentioned that on the show, but in the meantime, the team's capacity to provide one-on-one career advising has continued to go up, and we're eager to assist more of you in making, hopefully, better informed career decisions. You can apply for that at 80,000hours.org/advising. One new feature the advising team is building out is a system for recommending advisees to employers for specific opportunities. And it's probable that you're not always able to stay up to date on new organizations and openings in your area of interest because, how could you? But because there's just not enough hours in the day. And so it's handy to have the one-on-one team support you by keeping track of relevant opportunities that might come up and giving you a boost by affirmatively recommending you when there seems to be a great fit based on what you talked about in the conversation. Importantly, this is an opt-in part of the one-on-one service, so if you just want the advice, that is still there for you as well. Of course, we still can't advise everyone who applies, and sometimes we even have to say no to people because they already have such a sensible plan and it's not clear what value we can add. But nonetheless, I'll definitely encourage you to apply for career advising if you're considering trying to have a bigger impact in your career, or figuring out how you can build career capital so that you're in a better position to do good in future. Again, the address for that is 80,000hours.org/advising. All right, the 80,000 Hours podcast is produced and edited by Kieran Harris. Audio mastering and technical editing by Milo Maguire, Dominic Armstrong, and Ben Cordell. Full transcripts and an extensive collection of links to learn more are available on our site and put together by Katie Moore. Thanks for joining. Talk to you again soon.